Hello and welcome to Idaho Bigfoot. I'm your host, Jep. In today's episode, we're discussing how Sasquatch survive the cold. This is a question I saw come up repeatedly at about November of 2023 in some of the Facebook groups I'm in. And now that it's really cold, you can really see why people ask that question. It's a skeptically minded question. How does Sasquatch survive the cold? It gets really freezing in some places in North America. Some places get as cold as minus 60 degrees Fahrenheit, and that is freezing. Right now it's 7 degrees, and I'm starting to really feel the cold. The idea that an animal could survive in these kind of temperatures is pretty amazing, but the idea that a human-like creature or being could survive in these kind of temperatures or even colder, minus 20, minus 30 degrees, is really hard to swallow for a lot of people. Because if you're out in this kind of cold, you feel it. You don't feel like you can survive this. So how could something without all our clothes and without coffee survive this kind of cold? Survive the snow and the freezing winds? It's a really solid question to ask. And I'm hoping today I can provide just a little bit of an answer for y'all. It's something I've wondered a lot, and hopefully we can have a nice discussion. So we're going to move this inside into the lodge, Possum Lodge, and we're going to discuss this further. But remember to like, share, and subscribe, guys. Especially commenting down below. That's what gets a lot more YouTube reception, is if you leave a comment. Just anything, something super simple, means a lot to me. It really helps my channel. I want these videos to get more views, and if you could do that, that would mean a lot to me. Thank you, guys. All right, without any further ado, let's dive right in. Here we go.
A few moments later.
To dive right in here, I want to start by first going over some of the temperatures that you find in North America. I will probably make a PDF and drop it down below. If you don't see it, please remind me. Sometimes things get ahead and get away from me and I forget about it, but I should put a PDF down below and you can look at it. And these are just some of the numbers I collected. I will try to throw them up on screen, but they won't be up for too long. But as you can see here, I went by a few different factors and I kind of narrowed it down as we went. So in looking at the temperatures that you see for the United States, we actually did all of North America, but first for the United States, I took the coldest states on average. So anything above freezing, I set aside. And I took Alaska out of this simply because Alaska was quite a bit colder than most of the states here. And I did not want to skew the numbers to make it look colder than normal. We're looking at the United States. Alaska is a lot farther up in latitude. And so here's the number for Alaska. I don't want to leave it out of the equation, but just looking at the United States, the lower 48, if you will, and taking the coldest ones, we came out to an average of 22.92 degrees Fahrenheit. And the conversion to Celsius is up here as well. And then I wanted to look at, again, the coldest states, but then I wanted to take North Dakota and Nebraska out of the equation, because when you look at those two states, they don't have a lot of Bigfoot sightings. I think at most like 3 or 4. I mean, they aren't, you don't look at that and go, oh yeah, I'm going to find Bigfoot there. And this is according to the BFRO, of course. It's just the easiest place to access that information. I like the Bigfoot Mapping Project, but I'm still figuring out their page. So setting that aside, I was just looking at the BFRO. And as far as the BFRO goes, those two states had little to no, basically no Bigfoot sightings, right? In the grand scheme of things, very, very little. And of course, Alaska was also taken out of the equation in order to not skew the numbers. And then looking at the average here, it was an average of 23.52 degrees Fahrenheit. And then I wanted to look at Canada, and Canada was a little bit harder to access the information. I had to do some averaging. With the United States, all the numbers were averaged for me, but for Canada, I had to put a little bit of work in. And so I wanted to look at the two places where there were the most Bigfoot sightings. You'd think that there would be quite a few in places like the Yukon, but really there weren't. And that could just come down to a lack of reports. Like they happened, but no one went on the BFRO and told them. No Bigfoot researcher was able to get in contact with them, that sort of thing. Fairly remote areas, I don't know about how many people are up there, but I don't think there's a whole lot. So I didn't look into those. I just looked at the two that had the most sightings, and that would be British Columbia and Ontario. Now, to look at British Columbia, I had to look at the different areas in British Columbia. I had to look at central British Columbia and northern British Columbia as my sample. If anyone wants to go into this in more detail, I welcome them, and I would just like to hear what you collected. I'm just trying to keep it as simple as possible. And I took all the different areas where they collected the temperature, and then I averaged those up. So for central British Columbia, you're looking at an average of 36.25 degrees Fahrenheit. And then for northern British Columbia, averaging it out, you get an average of 31.14 degrees Fahrenheit, which combined, you get an overall average of 33.695 degrees Fahrenheit. Then for Ontario, we had to look at central Ontario, northwestern Ontario, and northeastern Ontario. So for central, I took all the numbers there and averaged them to 37 degrees Fahrenheit. Then for northwestern Ontario, an average of 25.57 degrees Fahrenheit. And then for northeastern Ontario, I'm looking at an average of 27.8 degrees Fahrenheit. And so the average between northeastern and northwestern Ontario was 26.68 degrees Fahrenheit. And then the overall average, which is just taking the average for northeastern and northwestern Ontario and then combining it with central Ontario, was an average of 31.84 degrees Fahrenheit. So then what I did was I looked at the United States again, and I realized that all of the states that I'd already listed were the coldest states, but they weren't necessarily concentrations of Bigfoot sightings. They had enough to meet a certain threshold, but they weren't concentrations. So I wanted to find out how warm or cold is it where a lot of the Bigfoot are sighted. And so I looked at the highest concentrations of Bigfoot sightings and figured out how warm it is or cold it is on average in winter, and then averaged them up. So you can see all the states here, including Idaho, because we have a fair bit of sightings here. And the average came out to 35.480 degrees Fahrenheit. And then what I did was I took the average winter temperatures where the highest concentrations of sightings happened in the United States, and I included Canada into it. So the United States, the numbers didn't change. And then adding in British Columbia's overall and Ontario's overall temperatures, you get an overall average, both combining the United States and Canada, for a combined average of 35.245 degrees Fahrenheit. Now, I know there will be a few people talking about how cold it can get. And for a few days out of the year, sometimes a week or more, you will get some very cold, very, very cold temperatures here in just the United States alone. I know in like Montana, you'll get minus 40 degree, even minus 60 degree Fahrenheit weather with wind chill factored in. And that is just nasty. That's brutal. So you do have to explain away how Bigfoot could survive that kind of weather. And that's something we may go into here in a satisfactory manner in a little bit. But, overall, looking at the temperatures for Canada and the United States, an average of 35.245 degrees Fahrenheit, that's actually not all that bad. Hair, or a fur covering, is something that every Bigfoot encounter I've read or heard about has included in its description. And according to the paper on the strength of hair across species, posted in the journal Matter, written by numerous authors, quote, "Hair provides vital protective qualities in many mammals. Structurally, it consists of a cortex with keratin fibers surrounded by cuticle scales. The exact hair structure, however, can differ in different mammals due to its functionality. For example, As the javelina raises its hair on its back when it is in danger, javelina hair has added stiffness provided by the cellular cortex. The hair of a capybara, which is a semi-aquatic animal, has a twin structure to create a biconcave cross-section to allow water to be removed easily. Guard hairs are composed of 3 layers. The shingle-like cells of the outer layer, or cuticle, seal off the interior of the hair. Pigments responsible for coloration are contained in the middle layer, or cortex, which may protrude into the innermost layer, or medulla, and make it appear to be pigmented. The medulla consists of a series of discrete air-filled cells, and air trapped within these cells can provide insulation against heat loss. According to Leonard Leroux III of the Deer of North America, a deer's color changes somewhat from summer to winter. To describe this difference in appearance, hunters and naturalists sometimes refer to deer as being in their red summer coats or blue winter coats. There are 2 complete hair molts per year. The exact time of the molt depends on the altitude, latitude, subspecies, physical condition, and age of the deer. Deer in the north shed their winter coats later and their summer coats earlier than deer in the south. Adult deer shed their coats before the young ones do, and those in good physical condition shed earlier than those in poor shape. My friend Manny Barone of Lincoln Park, New Jersey, is a taxidermist who constantly supplies me with bits of information and specimens that he encounters. His wife Elaine has also been of enormous help to me. On the night of December 15, 1976, Elaine did not get to bed until 4:00 a.m. because she sat up counting the number of hairs in a square inch of a deer's summer and on a square inch of winter coat for me. To my knowledge, no one has published such figures, and her findings were amazing. On a single square inch, 6.45 square centimeters of skin from the top of the neck of an adult buck taken in late November, there were 2,664 hairs. These hairs were 2 to 24 inches, 15 to 17 millimeters long, and had a diameter of 0.007 of an inch, or 0.1778 millimeters. An average-sized adult deer has about 1,200 square inches, or 7,740 square centimeters of skin covering. Using the above figures, we find that the deer has about 3,196,800 hairs in its winter coat. By applying the same calculations to Elaine's count of hairs on skin taken from a buck in the red killed in late August, I discovered that the summer coat actually has almost twice as many, 5,176 hairs to the square inch, or about 6,211,200 hairs. These counts explain why so many birds' nests are lined with deer hair. There must be gobs of it in any woods with a good deer population. The winter hairs are kinky, brittle, hollow, filled with air, and can be easily pulled out of the skin. Beneath these long guard hairs is a very soft, fine, kinky undercoat like cashmere wool. Elaine tried to count these undercoat hairs but also found it impossible. It is very difficult to see the undercoat, and when the wool was pulled out, it was so buoyant that it practically floated away. The long, hollow hairs combined with the undercoat give the deer terrific insulation, protection against the cold. Because the guard hairs are hollow, a deer in its winter coat floats much higher in water than it does in its summer coat. I have often seen a deer bedded down during a snowstorm with several inches of snow covering its body. None of the snow would melt because so little body heat was lost. Many hunters like to have a deerskin rug or throw piece. This is a waste of time and money unless the skin is to be used only as a wall hang. Because the winter hairs are hollow, they are very brittle. If they are walked on, they soon break off. There is one record of a Pennsylvania doe that had no guard hairs on her coat at all. Her entire body was covered with just the silky undercoat, although the undercoat hairs were longer than on a normal deer. This doe undoubtedly would not have survived the winter because the undercoat is not waterproof as the guard hairs are. In a freezing rain, this doe's hair would have become soaked, matted, and frozen. The deer of the far north have the darkest coats, while those in the south are quite a bit lighter. Deer of the desert or open areas are the palest of all. The difference in the color between the winter and summer coats is much more noticeable in the north than in the south. Because a deer's winter coat is so much heavier, I always assumed that it contained more hairs. So Elaine's count was a great surprise. The red of the summer coat extends about 80% of the hair length, while the basal 20% is grayish. The summer hair is about an inch, 25 millimeters, long and only about 0.003 inch, or 0.0762 millimeters in diameter. The hairs are thin, straight, solid, and without an undercoat. A summer deer skin can be used for a rug because the solid hairs are not brittle. Being solid, they provide little insulation, but they offer another kind of protection. The increased number of hairs shields a deer somewhat against biting insects. Whether the deer is in its dark winter coat or its reddish summer coat, the color tends to fade in the sun. The winter coat is more subject to bleaching because it is worn for a much longer period, 7 to 8 months, and is exposed to the sun more. In the winter, deer lie in the sun for warmth. They also feed more in the daylight hours, and with the leaves off the trees, the sun penetrates to the forest floor. So that was quite interesting. Now, according to John E. Russell and Ren Tumlison's paper, Comparison of Microstructure of White Winter Fur and Brown Summer Fur of Some Arctic Mammals, quote, it would be beneficial for the winter hair to be more insulative than the summer hair, particularly in mammals exposed to more extreme environmental temperatures to which they must adapt. Heat loss to the environment can be reduced by air trapped between the hair and the skin and increased hair density. Wider medullas would trap more air within a shaft, and more cells might increase the insulative capability of the hair in a manner, this word always trips me up, analogous to double-paned windows. Also, more cells could increase light scatter and make hair appear wider. Increasing the diameter of the upper shaft and decreasing that of the lower shaft would make the fur more pliable. Therefore, wind more likely glances over the fur rather than pushing it around. This would enhance the ability of the fur to retain air next to the skin, and thus form a barrier against the loss of heat held by the insulating hair. Also, decreased lower shaft size could allow for the production of a more dense coat, by providing room for more underfur hairs. Microstructural evaluation suggests that species examined display a variety of strategies for winter adaptation. All species except A. lagopus increase the amount of air trapped within the upper shaft of the white hairs. In all but L. arcticus, this was accomplished by increased width of the medulla and greater number of cells that comprise the medulla. The increase in the amount of air trapped in the winter guard hairs could result in hairs that are better insulators. Mustela nivalis also increased the width of the medulla and number of air cells within the lower shaft of the white winter hairs. Now, according to the Alaska Department of Fish and Game, some Arctic animals must maintain a difference in temperature of more than 180 degrees Fahrenheit between their body core and the surrounding environment. This is the equivalent of maintaining water at a boil in an environment at freezing temperatures. Body temperature can be maintained either by increasing the animal's heat production through metabolism, by decreasing the heat loss through insulation, or a combination of these methods. In cold areas, white fur actually provides greater insulation than darker colored fur. White hair is actually the result of no pigment within the hair. Because there is no pigment, the hair is hollow. Hollow air traps more air than solid hair. Try saying that 3 times fast. Because air is a poor heat conductor, air-filled hairs provide increased insulation. But don't darker colors absorb more heat from the sun? Yes, dark colors do absorb more heat from the sun, but in the Arctic and subarctic winter, the sun is not high enough to create any heat value. Some animals, such as doll, sheep, and mountain goats, are white year-round, while others molt. Molting from a summer coat of mottled brown to white not only conceals an animal during winter, but can also provide better insulation. Members of the deer family also have hollow hair, but that type of hair is of a different design and is hollow even though they have pigment within the hair structure. A deer's winter coat has hollow hairs, providing increased insulation. The summer coat has solid hairs, and surprisingly, there is more hair on the summer coat than the winter one. This protects against biting insects. So there's that bit of information again, repeated at the very end. All Bigfoot sightings again detail the Bigfoot being hairy. Their hair construction during the winter months, if they've adapted to the cold, would likely contain air pockets. Like it said there, having a wider medulla, and being in some of these environments, it can be very windy. So having if I remember correctly, it said a narrower hair structure at the base, but then it widens out at the top, would actually allow the wind to roll over top of it. Let's see here. Yeah, increasing the diameter of the upper shaft and decreasing that of the lower shaft. Making the wind go around you rather than pushing through your layers and getting to your core is important. Wind kills. The wind is incredibly deadly. If it's cold, adding wind to it just drops that temperature down considerably. Now I want to go into something here. The hairs that have been collected that seem to be that of a Sasquatch's. So now I want to go into the hairs that have been collected and seemingly belong to Sasquatch. If you look into them, as we will here in a second, you'll find that they seemingly do not depict a medulla at all. Now, I do want to say real quickly here that it's important to remember that Bigfoot researchers typically are not active during the winter. Most of the Bigfoot researchers I've seen tend to go out in summer. So that doesn't necessarily mean that Bigfoot do not develop a different winter coat. It just means that the hairs that have been collected were collected in a time period when they probably would not have adapted to the cold yet. I also want to say that I did try to do some probing into the Bigfoot community, both on my Idaho Bigfoot Instagram page and in the Bigfoot subreddit, trying to see if anyone has noticed any reports in these colder areas that seem to indicate either a white coat. That one I only posted on my Instagram page, though, to be fair. But then also whether or not there was a difference in appearance for the hair or fur in winter versus summer. And no one answered that, so at least not yet. I recently posted it, so I may get more responses on it as the video goes on, or as the production here goes on, as the weeks pass. But just the preliminary findings have not proven fruitful, so I do not know if they do shed or not, and we may touch on that here in a little bit. But just keep in mind that a lot of Bigfoot researchers don't go out in winter. Any of the hair samples that were collected in winter were probably accidental. Someone saw one and they got on the scene and they found hairs rather than people looking for it. And I would say that's probably the majority of hair samples. It wasn't from somebody looking for them. It was from somebody having a Bigfoot sighting and then they found hairs at the scene. So just kind of keep that in mind. So this is what Dr. Jeff Meldrum wrote in his book, Sasquatch, The Legend Meets Science. Splitting hairs and molecules, DNA and physical evidence. Footprints, with all they imply, constitute no more than trace evidence, and no matter how compelling they may be, no matter how anatomically appropriate and internally consistent they appear, they are merely suggestive of the presence of the Sasquatch. Whereas the hard evidence? The vexing absence of bones and teeth has already been discussed in light of the nature of soil chemistry in northwestern forests. Hair provides another physical remnant of the creature itself. Precise hair identification, trichilemmal, is, however, a challenging process requiring an extensive reference collection with which to compare the unknown sample. There can be considerable individual variation of hair length, color, texture, and stage of growth within a species, as well as variation between different regions on the body of a single individual animal. Arriving at a conclusive identification can be a labor-intensive process requiring exhaustive comparisons with known standards. In the past, there have been several independent analyses of hair attributed to Sasquatch, more often than not conducted at the request of an amateur investigator. Usually, the hairs were readily identified as belonging to a commonly known animal, such as bear, coyote, or human. However, some hair samples were of indeterminate identity. While an indeterminate identification of an alleged Sasquatch hair is interpreted by some as indication of an unknown animal, it is more conservatively regarded by others as the lack of a comprehensive collection of hair samples from known species of animals with which to compare the strand in question. Indeed, this would be the only reasonable outcome for hair that might in fact have come from a Sasquatch. All that could be concluded is what species the hair did not appear to belong to. Conclusive identification depends on a match to a known sample of hair, i.e. an established standard. Without a confirmed sample of Sasquatch hair, any hair truly originating from a Sasquatch would necessarily languish in the indeterminate category. Such a standard is unlikely to be acknowledged until hair is pulled directly from a Sasquatch body by a qualified analyst. Hairs obtained from the Bluff Creek area by Ivan Sanderson were submitted for analysis by Dr. F. Martin Duncan, who was in charge of the extensive hair collection at the London Zoo. Duncan stated that they could not be matched to any known North American mammal, but that they could be from an unknown large primate, based on common features shared with species of that order. Nearly a decade later, suspect hairs collected in central Idaho in 1968 were sent to Ray Pinker, an instructor of police science at California State College in Los Angeles. He likewise determined that the specimens did not match any sample of known animal that he had in his collection, but showed some characteristics common to humans and non-human primates. The hairs were light, showing variation in color and thickness along their length, unlike human hair, but exhibited a human-like scale pattern and lacked a continuous medullary core. The sample contained both coarse guard hairs and fine underhairs, uncharacteristic of primates. As suggestive as these observations might appear, Pinker reiterated that he could not identify the hairs as Sasquatch until he had a sample of authentic Sasquatch hair to match it to. I just want to emphasize real quick that the wording here is important. It said it lacked a continuous medullary core, meaning that there was some medulla present. It did not say that there was no medulla. It said it lacked a continuous medullary core. Just note that wording, please. So, continuing on, Dr. Sterling Bunnell, MD, a member of the California Academy of Sciences, conducted another hair analysis in 1993. Of a sample collected in Northern California, he said, "I've examined the hair specimen you provided from Damnation Creek," I love that name, "and compared it by light microscopy under direct and transmitted illumination with human, chimpanzee, gorilla, orangutan, and Pythagoras monkey hair. It is clearly related to the human, chimpanzee, gorilla group, but is distinguishable from each of these. On the basis of surface and internal structure, it seems more like gorilla hair than human or chimp. While by the same criteria, human and chimp appear closely related. The specimen hairs are remarkable in the extremely fine and diffuse pigmentation. The other species show dark melanin clumps and medullary streaks, and the absence of observable medullary structure. Such results have remained unimpressive or simply unknown to the scientific community at large. But as I discussed this challenging situation of the lack of a Sasquatch standard with Dr. Henner Fehrenbach, it occurred to us that if the indeterminate hair samples did in fact come from an unknown species of ape, there should be quite a suite of distinctive and distinguishing diagnostic features consistently characteristic of the suspect hairs. By backtracking to some of the labs and collecting their reports, it did appear that the indeterminate hairs displayed notably uniform characteristics and likely represented an uncatalogued single species of animal as their source. What are these characteristics of hair that form the basis of identification? In non-primate mammals, the hair is differentiated into three types. 1. Longer, coarser guard hairs which provide mechanical protection. 2. A finer undercoat of fur hairs which provide insulation. And 3. Stiff vibrissae or whiskers which serve as tactile organs. Of these types, the guard hairs are of the greatest diagnostic value. Primate hair is generally undifferentiated and has been described as possessing a modified combination of the characteristics of guard hairs and undercoat hairs. All hair varies, even single hairs from the same individual. In this way, hairs are rather like snowflakes. Therefore, a composite of characteristics occurring in all or most of the hairs in the reference sample is considered diagnostic. The outer layer of the hair shaft is called the cuticle. It consists of overlapping scales and may be thick or thin, clear or pigmented. The intermediate layer is the cortex, the main constituent of the shaft that gives the hair its texture. It contains keratinized cells and one of two types of pigment granules, melanin, brown, and phaleomelanin, blonde and red. Also present are cortical fusi, tiny air bubbles, and ovoid bodies, dark ovals, the functions of which are unknown. An innermost central channel, found only in large thick hairs, is the medulla. It varies in diameter and may be dark when empty and filled with air, or may be clear, although actually filled with cells. Other characteristics include the diameter, cross-sectional shape, and length of the hair shaft. The hairs of individual species tend to wear differently. Some hair ends fray and split, others wear to a blunted end. Human head hair is ever-growing, lengthening about 10 centimeters per year, and typically has a cut end that is easily recognized under magnification. The follicle structure is less well studied, but may also display distinctive features. These are complicated by the changes that accompany the hair growth cycle. Growing hair is said to be in the anagen phase, and the root appears as a stretched-out tangle. During the resting phase, or telogen phase, the root ends in a neat bulb. Fehrenbach has assembled over a dozen samples of hair that could not be attributed to any of the commonly known animals of North America, but which share a common suite of distinguishing features of the sort just discussed. Two of these samples are described in greater detail here. Unknown sample A averaged 8 inches or 20 centimeters in length, ranging from 3 inches to 15 inches, was dark reddish brown to black, wavy to slightly curly in parts, a mean diameter of 65 range 58 to 73 I forgot to look up what that term is, and I'm in an area with no Wi-Fi, so I apologize. Cross-section round to slightly flattened entire length.
Medulla absent, minimal fragmentary medulla in one region. Cuticle pigmentation showed an irregularly waved mosaic pattern. Scale margins were smooth to mildly crenulated or wrinkled. Distance between scales intermediate, 9 to 12 scales per 100 linear distance.
Most hares were in the telogen stage of hair growth cycle. That is, they were ready to fall out on their own. A few strands had follicles attached. Some of the hairs had split ends, i.e. a brush-like tip, whereas most had smoothly rounded, worn tips. None were cut. Unknown sample B averaged 3.4 inches, 8.5 centimeters, in length, ranging from 2 to 5 inches, was reddish-brown to blonde. It was identical in anatomy to sample A, except for the complete absence of a medulla. All hairs had attached follicles. Neither sample shows any indication of being cut. These samples were taken from adjacent fresh twist-offs, Fehrenbach noted. They came clearly from the same species, but from two different individuals, one light reddish-brown with an average length of 4 inches, worn ends, the other with dark reddish-brown, black to the naked eye, average length 8 inches. Two Sasquatches matching these colors were observed within 20 minutes of the immediate vicinity of the twist-offs by several eyewitnesses. None of the witnesses had the prerequisite hair color or morphology. So basically, the eyewitnesses seem to indicate that these were genuine hairs. They confirmed that those, were real individuals. However, it must be stated that they could have placed those hairs there and then claimed that they saw something. But I see some problems with that. So continuing on. The anatomy of the hair samples ruled out the common mammals of the region. There was no feature that absolutely ruled out identification as human hair, although the lack of cut ends on relatively short hairs seemed to make a human source quite unlikely. The glitch in the absolute determination of the hair, conceded Fehrenbach, is the fact that some human hair can have a similar appearance. And yet, the circumstantial evidence of the discovery combined with the anatomy seemed to leave the Sasquatch option open. So it just kind of goes on. And it goes on about sequencing DNA and trying to gather DNA. It's quite a good book so far. I've not read it through, but I've read bits and pieces, and so far I really like it, and I love that cover photo. It looks great. I want to look at what another author had to say on this topic. This is the book Rain Coast Sasquatch by J. Robert Alley. Most of the book talks about Alaska, but he does go down into Northwest Washington a little bit, talking about some of the native legends and whatnot, and he's done a lot of footwork. He has recorded a lot of sightings that you won't find on the BFRO's website. One of the things he noted is that a lot of the Bigfoot sightings up there are kind of kept within a family. Most people don't go out and talk about them, either for fear of ridicule or it's kind of considered a private matter. It's kind of taboo to go out and talk about it in public for a lot of the people, especially the older community and native community. And so, getting your boots on the ground, having a rapport with people, you'll hear things that otherwise you wouldn't even know existed. So he's gathered some fascinating reports in here. I feel like this is a worthwhile book for you to purchase. So far, I have to say the same about Sasquatch Legend Meets Science, but this one I've sat through and have tried to read through. I have like 4 other books I'm trying to read through, so every one of them I'm going through very, very slowly. But I'm getting through them. Anyway, this is chapter 15, Traces of Hair and Missing Bones. Now, we're not going into the missing bones part, but just the hair. It says, a collection of matching hairs found in association with alleged Sasquatch tracks or sightings from more than 10 different locations in western North America has been well studied and described by Dr. W. H. Fehrenbach of Beaverton, Oregon. The result of Dr. Fehrenbach's work by itself is suggestive of a new species or subtype even without recourse to mitochondrial DNA analysis. DNA analysis is straightforward and expensive to perform on freshly obtained hair and next to impossible on old hair that does not have a hollow center or medulla, such as human or alleged Sasquatch hair. It is quite impossible to perform on old samples that do not have a root or follicle, the growing, living bulb end of the hair that contains the only few real cells in the hair itself. It is this bulb, collected fresh and handled correctly, that is required for a DNA fingerprint. And hair does not usually detach from the body complete with a follicle unless someone has walked up to the living hair and plucked it or found it on barbed wire. Alaska, unfortunately, does not have much barbed wire. All mammals have hair, and all known mammals may be identified, at least to the genus level, by the length, thickness, cross-sectional shape, medullary canal configuration, and external scale pattern of their hair. Reports of strange hairs of unusual length or color, which by their description do not match that of previously identified mammals, are not common. However, Bindernagel, that's Dr. John Bindernagel, may he rest in peace, has noted that hair attributed to Sasquatch has been recovered from apparent Sasquatch beds, shrubbery, fences, and trees, all where sightings have occurred. It is some consolation that in at least a few cases some samples of hair have been kept. The most frustrating aspect of hair analysis, at least to Sasquatch researchers, is the bland statement heard more than once from law enforcement and fish and wildlife departments who have analyzed the hair given them. It didn't match anything we have on record. We threw it all out. Such a rude thing to do. In spite of this, there exists among many casual Sasquatch researchers the naive belief that the same laboratory staff who couldn't match the samples would persist in the endeavor to find some higher agency who had a more complete collection of hair. 2 points arise here. Firstly, if more paperwork is necessary and the analysis of the hair isn't an official department task, the work ends immediately along with the sample. These good government, or too often university and museum, employees are not particularly interested in spending much of their time discovering a new species and work daily within the realm of what is already known to science. No more. Secondly, there are just no known samples of Sasquatch hair with which to compare reported hair in any local fish and wildlife agency offices. In southeast Alaska and elsewhere, there have been hairs regularly collected in the bush, on trees, or in peculiar nests that do not match the long hair of bears, wolves, moose, porcupines, elk, or wolverines. From Alaska, I have only 3 reports of possible Sasquatch hair, including one with a sample currently under analysis. The mentioned collection of hair attributed to Sasquatches has been subjected to microscopic scrutiny by Dr. Fehrenbach, whose work has included specialization in the field of primate studies. While his collection contains more than 10 hair samples of a peculiar and matching structure collected in association with reported Sasquatch sightings, tracks, and so on, he and his colleagues have found DNA sequencing to be frustrating and, at this time, perhaps not terribly useful. The recent state of matters regarding Sasquatch hair may be best summed up in his own words in a reply to individuals seeking information about field collection of purported Sasquatch hair. Fehrenbach stated in February 2000, "There is no absolutely identified Bigfoot hair. I have collected 12 samples from 4 states, all collected under suggestive or excellent circumstances. They measure from 3 to 15 inches in length, are all under 90 microns in diameter, all have a reddish tinge under the microscope, and all are lacking medulla. You can find human hair like that, but a dozen samples like that collected independently are not suggestive of hoaxing. DNA analysis is futile since the mitochondrial DNA appears too fragmented to allow for sequencing. Possibly a function of no medulla, same problem with human hair of that structure." In the most recent Alaska report of hair I have, the hair described was not too unordinary, nor was any sample collected. One Ketchikan hunter with more than 20 years of deer and bear hunting experience stated to me in 1999 he had found some curious hair in a freshly made nest. The nest, described in the chapter on Sasquatch nests, discovered in early fall, 1988, was circular in form with a rough rim, and although small, it was woven in appearance and was made of fresh huckleberry and cedar. I did not feel it was a bear nest. In it, I found black hair, longer than a bear's, well over 4 inches in length. Of course, there is nothing to prove it belonged to a Sasquatch, but given the poor time of year for a bear to be readying a winter hibernaculum and the appearance of the long hair, it is rather more likely that it had been recently constructed by a Sasquatch. The second report of hair is similar. No sample was collected, but the details are quite a bit more remarkable. In a track report given in 1999 by retired Saxman fisherman Tom Abbott, then of Haines, the witness told me that he had been seal hunting with a friend in April 1974 on Tyasanka Inlet, 10 miles north of Haines. He further told me of finding an 18-inch Sasquatch track on the beach by an area of trampled grass, blood, and wolf tracks. What surprised him and his partner as much as the track was a big hank of light brown hair, approximately 18 inches long. Mr. Abbott told me quite frankly he has since really regretted not hunting with a camera or thinking to pick up some of the long hair. Although shorter, 4-inch hair is the usual length stated in Sasquatch reports both in Alaska and along the BC coast. A number of both modern and historical reports up and down the coast report the observation of some individuals with long hair on the head, the back of the head and neck, sometimes the shoulders, and occasionally down the back or the arms. Whether this unusually long hair represents a gender-based difference, male being the candidate on the basis of primate studies, a variation within the species or a different species entirely, has obviously not been determined at this time, nor will the acquisition of the first body or anatomical part solve that question. In the meantime, it may be that some hair or bone will identify the genus and species of this hominid, and the next report will touch on that. In a previously noted Kloak Lake nest report, a forestry worker discovered dark hair, nearby hand scratches on a tree, as well as large droppings nearby. The nest was photographed, and the hair sent to a certain state lab was found not to match any of the known animals of Alaska and promptly discarded. I would be so angry if they threw out a hair sample I collected. That would just run me up the wall. It says here the fecal sample, approximately 1 gallon in volume. That's a lot of poop.
That is one big pile of shit.
Was bagged and frozen, but has not been submitted for analysis and remains in the possession of one of the principal investigators. The nest was subsequently destroyed by a fire through the area, and the large cedar fell on it as well. At this time, nothing recognizable remains except one single sample hair obtained from the Kloak Lake nest, currently under study. The collection of hair in the field should be carried out with the possibility of securing a hair with the follicle at its base intact. This greatly increases the possibility of successful DNA examinations if the sample is fresh and forwarded promptly to a lab. Now, this is important to note because if you ever have the opportunity to collect a hair sample, this is what you need to know. Carry a sealed bottle of sterile isotonic saline, 0.9% saline, which is readily available. If more than a day from a lab, refrigeration would be useful to retard bacterial growth. The saline would function to keep the follicles from dehydrating. If sent by airmail, the container should be no more than 2/3 full and taped closed. Shipping in a refrigerant, such as dry ice, should be adequate. Even if DNA cultures are not productive and evidence of the species is not obtained this way, the assembly of a collection of similar hair will probably prove useful in providing a reference for future possible Sasquatch hair samples. So I thought that was very interesting. Again, great book. Great books. I've really enjoyed them so far. But again, I've read through most of J. Robert Alley's book here. And I've read through parts of Sasquatch: The Legend Meets Science, and so far I'm really enjoying them. So just thought I'd say that there. I found it interesting to hear about how, first of all, some of the samples that have been collected were thrown out. And again, that would just really piss me off. I have collected some hair samples, but I have a sneaking suspicion they're elk, which is why I've not acted on it, and I'm wondering if I should send any of them in. Part of the problem too is that I had originally put them in a plastic bag, and it wasn't until later that I found out, because this was in 2020 actually, it wasn't until later that I found out that putting anything that contains a DNA sample in plastic will actually degrade the DNA sample. So I think the best option I would have, because I kept it in there for about 2.5, 3 years, would be to just have the samples just kind of examined like Dr. Fehrenbach and Dr. Meldrum do, looking at it under a microscope. I was still pretty new to all this, so I've grown a little bit in my knowledge, and hopefully that will help you as well. You'll want to bring yourself a mask or two, and all that is to stop you from spitting on the sample. So if you have any handprints that are on your window, and if it looks like there was sweat on there, or if there's any kind of like saliva on there. Some people have reported having saliva on their car. It looked like the creature drooled almost. It's kind of a gross thought. Being able to stop yourself from possibly contaminating the scene is good. I bring my camera with more often than not just from the standpoint of, yeah, I want to record a Bigfoot if I see one. Really more because if I get a sample, I want to record myself taking that sample. I want to show how careful I was, and not just say, well, I was careful, trust me, bro. Like, no one really trusts anyone anymore. So just showing how you collected the sample, I think, is important. So I would recommend doing that if you have your phone, getting a simple tripod mount for that and a cheap little tripod. It may prove to be useful. Or having a chest mount. You can just throw that chest mount on, get your phone or GoPro going, and you just kind of record yourself taking the sample. Whatever. I haven't gotten out into the field for a while because of my leg, so I'm not too worried about this, but I'm trying to figure out exactly what I want to do. I do know I want to get a few paper bags that are for crime scenes. You can seal them up, and I want to bring my folding saw with me, so if I ever see any twists, twisted off trees, I can cut the piece that was clearly held by the hands and twisted. I can cut that off completely and carefully put it into the bag, again wearing mask and gloves, seal that up, and then send that off to a lab in order for them to take a DNA sample and see if there's any touched DNA. If it looks fresh. If it's old, there's no point in doing that, but a fresh one, yes. It's just trying to have multiple samples, so that way if they do throw it out, you at least have another one that you can send to somebody else. That's the key. Don't put all your eggs in one basket. Just because you would be careful does not mean someone else would be. Just saying. So let's move on here with the rest of the video, shall we? The metabolism factored in. According to the article, Rapid Metabolism Change Helped Mammals to Thrive in Colder Climate, posted on physics.org and published by the University of Reading, quote, a new study published in Nature reveals that the ancestors of mammals benefited in the evolutionary race owing to their ability to adapt their metabolism beyond the constraints imposed by body temperature. They were able to colonize colder environments or high latitudes, allowing them to thrive when Earth's climate cooled. The basal metabolic rate of animals, the rate at which energy is used to maintain the body, was previously thought to be intimately linked with an animal's body temperature. However, this research shows mammals were able to decouple this relationship to allow their metabolism to evolve rapidly and adapt over 165 million years. Dr. George Avaria Lartonero, I'm sorry, I can't say his name properly. If I get any names or places wrong, if I pronounce them incorrectly, I do apologize. He's an evolutionary biologist at the University of Reading and lead author of the study, said, the research shifts the emphasis to understand the origin of mammalian metabolic diversity as a response to the rate at which they lose heat to the environment. Colder environments increase the rate of heat loss from mammals, and to maintain the body temperature constant, this loss is subsequently compensated for by increasing the metabolic rates as long as resources are available to fuel the metabolic elevation. Previous research worked on the principle that body temperature and metabolism were closely aligned because metabolism is the primary source of heat and the body temperature itself affects the metabolic rates. However, the new study found that natural selection was able to quickly adapt animals' metabolisms irrespective of body temperature. This was true for over 90% of ancestral mammals, including bats, this is the one I struggle with, carnivorous? I think they meant the right carnivores, but they wrote carnivorous, so I don't know what that's about. That's an oops, I think. So let's back up here, including bats, carnivores, I feel is likely, hedgehogs, marsupials, primates, rabbits, rodents, and even-toed ungulates. If there's another option for what that could have stood for, please let me know. Dr. Chris Venditti, evolutionary biologist at the University of Reading and co-author of the paper, said, the paper has challenged the assumption of ecological and evolutionary theories that basal metabolism evolved hand-in-hand with body temperature. These physiological traits evolved under distinct selection pressures, causing different routes to their modern diversity. It also helps us to understand the evolutionary advantages that have led to the diversity of the energy expenditure in mammals. And according to Leonard Lee Roux III, the deer of North America, once again, in most warm-blooded creatures, man included, the basic metabolic rate speeds up as the temperature drops. Basic metabolism is a measure of energy requirements, since if a creature's body temperature is to be maintained, heat production must equal heat loss. It is like running a furnace under forced draft. You can raise the temperature, but this requires extra fuel. This is why it is vital for anyone who expects to be out in cold weather to carry emergency food to prevent hypothermia. A few years ago, biologists discovered to their great surprise that a deer does not respond to cold in this manner. It has been known that young animals of all species have a higher basic metabolic rate than adult animals, and that the larger species have a lower basic metabolic rate in proportion to their body size than the smaller species. This is another reason why the northern members of a single species are larger than are their southern counterparts. And according to the paper, basal metabolic rate in carnivores is associated with diet after controlling for phylogeny, published in the journal Physiological and Biochemical Zoology, quote, activity hypothesis. Carnivorous species tend to have larger home ranges than species that eat vegetable matter. According to Garland et al., 1993, in simple and adaptive terms, this difference in home range has been explained by the higher trophic level occupied by carnivores, which means that their food is more widely dispersed and offers fewer joules per unit home range area than does the food of herbivores. Higher BMRs, or basal metabolic rates, of carnivores, then, could be a consequence of the fact that they expend more energy to pursue, kill, and handle their prey. In this scenario, higher metabolic rates would be related to higher levels of activity as estimated by home range size. According to the activity hypothesis, correlation between BMR and diet would be a byproduct of the relationship between activity and diet. Food quality hypothesis. The food quality hypothesis states that carnivorous species tend to have larger BMRs because the food items they consume are more digestible, are free from chemical deterrents, and are generally available throughout the year. On the other hand, vegetarian species have lower metabolic rates because plant material is poorly digestible, is more likely to have chemical deterrents, and is less available during some seasons, and more non-nutritive substances are usually ingested with them. New directions. Muscle performance hypothesis. Identification of a correlation among metabolism, diet, and home range size is necessary, but not complete if one wants to understand how natural selection has brought about elevated oxygen consumption in meat eaters. So where do we go from here? We develop a new hypothesis, the muscle performance hypothesis, that states that BMR, basal metabolic rates, is elevated in vertebrate-eating carnivores because natural selection has designed their muscle structure for endurance rather than power, and the resulting increase in mitochondria density, in particular muscle fiber types, requires elevated oxygen consumption. Foraging for vertebrate prey typically requires movement over large distances. One can imagine that selection has maximized efficiency of muscle movement in these species. When species include vegetable material in their diet, home range size can be decreased. Therefore, endurance requirements of their muscle tissue may be reduced, or power requirements of muscles may be increased as a result of species becoming more arboreal. Conclusions. Species that eat meat have larger home ranges and higher metabolic rates, whereas those species that consume vegetable matter have smaller home ranges and lower BMRs. So that's a lot of information there. This really, though, is interesting, that last part. I think Sasquatch being carnivorous in nature explains their lack of constant sightings in any one area, if they roam like wolves and other predators do. It would also explain the lack of fecal matter. Vegetable matter, at least in humans and many animals, is much harder to absorb and thus more scat is made. Predators seem to poop far less, and the scat that they produce typically contains mostly hair when they do, and it can blend in quite well. Carnivore scat also doesn't smell as bad. I can always tell when cows have been in a section of forest, not just because of, the amount of patties, because there typically is a lot, because a whole herd came through, but also because of the smell. I mean, if you were blindfolded, you would know that there are cows there. It's smelly. You can pick up on that smell. Bigfoot being a carnivore would also explain their behavior better. They are elusive and like to observe humans from behind cover, and don't usually tend to flee very far when they run away. According to some, they also seem to approach trail cameras from behind and kind of peer around to look at it, or come in from the sides, much like a predator would do to a prey animal, investigating it from a blind spot. And that is consistent with a cautious predator rather than a prey animal. And point in fact, my dad was almost attacked by a mountain lion last year. I did a full interview with him on my YouTube channel, Jep's Outdoor Adventures. And that's exactly what the thing did. It came in. It sounds like it may have come around from behind and then kind of came towards him from his left side, kind of out of his field of view. He happened to get a glimpse of something. He turned and looked, and there it was. And it was about ready to lift that paw over the fallen tree. And once it had done that, he thinks it would have pounced on him, and thankfully he saw it and killed it. But that's exactly what the mountain lion did, is it came around and attacked from the side. Or at least it was trying to attack from the side. It thankfully did not have the ability to. And another thought is that, as sad as this is, a lot of missing 411 disappearances indicate a person went missing right before bad weather. Now, you know, people have different opinions about David Paulides. I know some people love him, some people hate him. I've been very interested in his research. Some of his cases apparently weren't researched very well. The ones I've researched have been pretty good, but you know, sometimes it is hard to find enough information online to really investigate the cases. You have to get in person to do it, and he does seem to try that. But you know, he is a very interesting person. I don't agree with him on a lot of things, so just keep that in mind. But some of the cases I have researched, yeah, I have confirmed that everything he said did happen. So just thought I'd put that in there, except for one case in which we'll talk about it in a moment, but he said that the guy may have been hunting for caribou. There were no caribou for him to hunt. He was hunting deer, and that was a detail that he kind of messed up. But otherwise, I haven't found any glaring issues with the details that he puts out there. But, you know, there are a number of different circumstances that could cause someone to go missing. But animals can typically tell beforehand when bad weather is about to hit, and this is the disturbing part. It's possible, as gruesome a thought as this is, that Bigfoot kidnap and possibly kill and eat some people, which could explain why right before a bad storm someone disappears and they aren't ever found. A case that I'm thinking of, and this is where he said the guy was caribou hunting maybe, and he wasn't. He didn't state that as fact, but he said he could have been, and no, that was not the case. Was this, the case of Robert Smith. He went missing, and the poor man, I mean, there was absolutely no reason for him to walk off. He, you know, there was a trail that he was going to walk, but past that, he would not have tried to go off unless he shot a deer. And even then, you know, it had to have been within walking distance, and people combed the area thoroughly, and the man would not have been able to walk very far. He had just finished beating cancer, and then he went missing. I mean, it's a truly heartbreaking case, and I mean no disrespect to the family by bringing his name up. But he was wearing a lot of blaze orange, and he was never found to this day, as far as I know. And he was armed with a 30-06, and they heard, supposedly his wife heard one shot fired off around the time of his disappearance, and it could very well have been him. No blood was found. Scent tracking dogs did not find him, which means that there was probably no blood spilled on the scene. It's just, it was a curious case, and I went into that in more detail in the Hunter Becomes the Hunted Robert Smith case. It happened in Maine, and I recommend you check that out if you feel like it. It's a little bit older, but it's still a pretty good video, I think. But it's a sad case, it really is, but it does kind of feel like that could be what happened, was he was kidnapped, because there aren't a whole lot of explanations for what happened that seem to really fit. We did go into a few other options, though, to be fair. But, you know, the fact that hunters have reported their kills being stolen from them, and this book has gone into a couple, indicates the Sasquatch seeing an easy meal and taking it, which makes sense logistically because most of these cases occur in late fall, right before winter, or at the beginning of winter when they need the calories the most. And there's also the fact that hunters have reported their kills, their deer, for example, being stolen from them, as reported in this book. And that indicates that a Bigfoot saw an easy meal and took it, which makes sense logistically because most of these cases occur in late fall, right before winter, or at the very beginning of winter when they would need the calories the most. People have seen a Bigfoot attacking and killing a deer, but the raw nutrition provided by... People have also seen a Bigfoot attacking and killing a deer, and the raw nutrition provided by the meat and the marrow of the bones. And a fellow I talked to at that Sasquatch Valley Roundup told me that he had found a bone, a deer leg bone, that had been twisted apart and broken. It didn't seem to have any impact marks, but seemed to have been violently twisted. That would imply that the action was intended to access the marrow. I really don't see any other reason for that. And, you know, the marrow, the fat, is very much needed for a creature in that kind of weather. Plants can provide enough nutrition if you can find them, but they would probably need 4 stomachs, and that is not something that humans or apes possess. Most of the creatures that you see out in the woods that eat plant material have 4 stomachs. Bigfoot would conceivably not have that. So theoretically, winter would be the most difficult time to survive in, but seeing as how most areas where they're sighted in don't typically have bad weather temperatures, you can see how a Bigfoot could survive. And if they eat meat, it would make sense with their behavior and some of the things that have been attributed to Sasquatch, with the large home ranges, only occasionally being seen, all of that. But I want to go into this a little bit further. We're going to examine mountain gorillas, huskies, the people of the Andes, bison, polar bears, mountain goats, deer, and caribou to see if there are any adaptations across the board that they have for winter survival that could be applied to Sasquatch. In rainy weather, a mountain gorilla's long hair helps keep them warm by creating a pocket of insulation around them. As their name implies, mountain gorillas live in the forests high in the mountains at elevations of 8,000 to 13,000 feet. They have thicker fur and more of it compared to other great apes. The fur helps them to survive in a habitat where temperatures often drop below freezing. There was also a bit in here that I think I accidentally deleted, but it was that mountain gorilla's biggest enemy is the rain. But they tend to just kind of sit it out and wait for the rain to stop, and they move on. The weather there is much like over in Washington. It's very rainy. It's definitely a rainforest. They get constant rain, and they just kind of sit it out, and then they kind of move on. And you can kind of see the steam rising from their bodies in that heat that their bodies produce, and from the sun coming out again. And they're back on the move, and they're good again. And so you could expect that to happen with Bigfoot, more than likely. I don't know why I accidentally deleted that. I had a horrible time with Microsoft Word trying to assemble the document, so I apologize for that. Let's move on to huskies. Huskies can withstand temperatures as low as minus 58 degrees Fahrenheit, assuming that the husky is a healthy adult with no existing problems. But yet huskies can get cold, especially if they are wet. Once your husky is wet, their ability to stay warm is significantly impacted, and they will not be as resilient. There are stories of mushers who, when considering buying a new husky, try the dog for the night, letting him sleep on the snow. If the snow is melted there in the morning, the dog is labeled a melter and returned. Being a melter would indicate the dog gave off too much body heat and could be overly susceptible to the cold. Northern breeds have evolved for thousands of years to keep warm under frigid conditions. These breeds are the dogs we tend to think of as Spitz-like, with thick standoff coats, small pricked ears, and medium to stocky builds. They include breeds such as the Siberian Husky, Alaskan Malamute, Samoyed, as well as mixes of Husky-type dogs. When the temperature plunged to minus 130 degrees Fahrenheit, with the wind chill factored in. I checked this is legitimate. Minus 130 degrees Fahrenheit with wind chill. In the 1973 Iditarod, it was the mushers, not the dogs, who complained. But there are limits. When a dog's body temperature goes below 98.6 degrees Fahrenheit, cells begin to have problems functioning properly. When the temperature goes up above 108 degrees Fahrenheit for a sustained period, cells begin to die. The dog must keep his body temperature within this range. Since heat is lost from the surface of the body, the more surface area an animal has, the more heat it loses. Larger animals have a lower surface area to volume ratio than smaller animals, so they radiate less body heat per unit of mass and stay warmer in the cold. To retain heat, you want the least body surface area compared to body volume. In other words, you want a sphere. The stocky northern dog is a compromise between the need for a big, thick-set body and a build that enables it to pull freight or cover ground. The dog uses his behavior to modify his effective body conformation when it sleeps curled up in a ball, making itself as spherical as possible. Sleeping in a ball also has one more advantage. By tucking the nose under his tail, not only is the bare, moist nose protected, but the air the dog inhales is warmed from heat trapped between the tail and the body. That's a helicopter going overhead if anyone can hear it. Now, I have rarely heard of any Sasquatch that reached over 8.5 to 9 feet in height. Even in Alaska, actually, most of the sightings in this book are between 7 to 8 feet in height. That height may be the ideal size for a Bigfoot. Just large enough to scare off predators and stay warm, but not so large as to make moving around difficult, if not nigh impossible, in snow, mud, and muck. Their feet are likely much like the hooves of a moose, where they are large in proportion to the body. In deep, soft substrate like snow or mud, the dew claws of a moose touch the ground and the split hoof can splay. This increases the surface area of the foot supporting the moose's weight and, like snowshoes, can help prevent the animal from sinking. Alright guys, I am back. It's another day and another hour, but I am ready to keep going in the video, so hopefully you are too. According to Life Nature Library's Land and Wildlife of Eurasia, the European elk, close cousin to the American moose, were tamed by the Soviet Union to use in the taeda and tundra. They can haul 1,100-pound loads at a trot over ice and snow without getting bogged down like automotive equipment. The biggest issue an animal in the North faces is keeping its body appendages warm. The solution to this problem is present in many northern species. Body appendages tend to get smaller in the north as a heat conservation measure. Snowshoe hares have smaller ears than cottontail rabbits. Mammalian legs and snouts are frequently shorter and stouter. According to Bigfoot researcher Michael Thompson, who we got to, I didn't actually meet him, but I got to listen to him over at the 3rd annual Sasquatch Roundup in Spokane Valley, Washington. We traveled a few hours to get there and paid good money to see it, and he was one of the speakers. Unfortunately, the prior speaker, right before him, was causing a lot of noise in the background, laughing and talking and raising their voices repeatedly, him and a woman who I did meet. She didn't give me a bad impression, but, you know, it was very rude behavior. They knew better. Just flat out, they knew better. And, you know, Michael Thompson, he traveled all the way from Alaska, and they talked right over him. And that's not nice. So if you go there again, feel free to speak up if that happens, because it's not the first time it's happened. Yeah. So with that out of the way, that little rant set aside, I did enjoy most of that Bigfoot conference. It was my first one. Never gone to one before that. And hopefully I'll go to more this year. So long as my leg permits it and we have the ability. We may not, I don't know. But Michael Thompson's part was pretty good from what I remember and what I could hear. And he talked about how the boreal Sasquatch, which is one of the more common types of Bigfoot reported up there, he's kind of divided them up into different types. And the boreal Sasquatch, he says, if I remember correctly, again, have shorter arms proportionately than your average Sasquatch would. Because a lot of people report that Bigfoot, their arms go down to their knees. Now that isn't because their arms are that long, it's because they have relatively long arms. I know I have a pretty sizable wingspan. I have a 6'6" wingspan, and I stand 6'1" tall. So, you know, I have a pretty sizable wingspan. If I slump forward, have a bad posture, and let my arms hang, yes, my arms are about where my knees are, give or take. So that is not necessarily because they have really long arms, like orangutan-like arms, but it's because their arms are somewhat long proportionally, not much longer than ours, but just enough to seem a little off. And with that bad posture, you know, their arms do seem quite long. But with the boreal Sasquatch, they're typically reported as having shorter arms. Now, this actually makes sense if that is true, because if we look at what the book Life Nature Library, The Mountains, had to say about the Andean people, I think it ties in very interestingly. So let's get started here. To quote, "The Andean Indian is a kind of underprivileged Superman. Though poorly fed and badly overworked, he has evolved into one of the physical marvels of the world, having become uniquely adapted to the harsh conditions of high-altitude life. On the 13,000-foot Altiplano tableland, the air pressure is about 8 pounds per square inch compared to 15 pounds at sea level, and the temperature drops below freezing almost daily throughout much of the year. To meet the problem of thin air, the Indian has acquired a set of oversized lungs and an oversized chest, and his blood and tissues make extremely efficient use of oxygen. To resist cold, generations of adaptive mutations have given the Indian stumpy arms and legs and a short torso, so that his blood has a shorter distance in which to circulate. With many capillaries to warm his extremities, he can walk barefoot in snow without ill effect. But in spite of his physical adaptation to the heights, the Indian has a hard time of it there. Though his Incan ancestors once ruled the Altiplano, he is now pathetically exploited. As a tenant farmer, he works only for permission to grow crops of his own. His diet is invariable: beans, potatoes, quinoa, and rarely a little mutton. Dysentery and whooping cough take many of his children, and he himself does not live long. The terms of life are different in the mountains and usually harder for man. Basically, they are set by three controlling influences and the ways in which these combine. The ruling factors are the terrain of the mountains, the climate, and the isolation from the rest of mankind that mountain living enforces. Of these, terrain is the most important. Even in the most favored climates, the mountains put forward constraints that weigh upon life. These may be overcome, but the price is high. The tilt of the land makes everything more laborious. Extra energy must be expended not only to drag burdens uphill, but also to break their descent. Every hillside field requires more work. The slope, moreover, is not simply a passive foe. It drags the very earth of man's fields downhill. In many upland spots near the equator, there are no such changes of season as most of us are used to. In certain regions of the Bolivian, Peruvian Andes, the climate is eternal springtime. Peach trees bloom all year long and fields yield several crops annually. In fact, the environment all in these areas is agreeable enough to have fostered the development of the continent's only great native civilization, that of the Incas. In the course of the Andean civilization's 4,000-year development, millions of people occupied the high valleys of the central Andes, and many of them established themselves long ago in some of the highest permanent habitations on Earth. At extreme heights, however, the advantages of high-altitude equatorial living vanish. The air gets too thin and cold to be called friendly. For the ordinary run of mankind, in fact, the climate in the high Andes is so unfavorable that it poses what seems to be an almost unsolvable problem in survival. How does one get enough air up there to breathe? Most of us live near the very bottom of a 10,000-mile deep ocean of air. This air, having weight and being compressible, becomes denser as it gets deeper. At sea level, a man is adapted to this density, or pressure, which is 15 pounds per square inch, and his lungs are so constructed that when he breathes in a gulp of air, the 15-pound pressure will force a sufficient supply of oxygen through the thin linings of his lungs to give his blood what it needs. But as one goes higher, the pressure is reduced. At 10,000 feet, it is down to only 10 pounds, which is not quite enough to push an adequate amount of oxygen through the linings of the lungs. As a result, the blood may carry as much as 15% less than its normal load of oxygen, and the lack may cause headaches, fatigue, and shortness of breath. At 18,000 feet, the air pressure is only half what it is at sea level, and few people will escape more pronounced symptoms. Unless the human body somehow can overcome the shortage and keep its vital oxygen balance, it will sicken and die. Yet in the high Andes and in Tibet, people not only survive at such heights, but live their whole lives there, working and playing as normally as the rest of us do at sea level. Clearly, these people have made tremendous use of what their communities have learned over the centuries about adjusting their daily activities to an extreme environment. But more important, they have overcome the altitude problem permanently by a dramatic adaptation. They have become physically different from the rest of us, mainly by changes in their respiratory and blood circulating systems. One of the first things a visitor to the high Andes notices is that the stocky inhabitants of these mountain slopes have tremendous barrel-shaped chests, and they have lungs to match. Furthermore, the small pockets or alveoli which line the lungs and give added lung capacity are, in these people, always open wide. This lets the greatest possible amount of blood flow through the delicate lung tissues and thus pick up all possible oxygen that is breathed in. The Indian of the high Andes has about 20% more blood than a lowlander. This extra blood is made up largely of red corpuscles, because it is red corpuscles that hold the all-important hemoglobin, which catches and absorbs oxygen. In Indians living at 15,000 feet, there is an increase of almost 60% by weight of this vital hemoglobin. Each of their red blood cells, moreover, is larger than the cells of lowland people, this larger size giving a greater surface for the absorption of oxygen. Because the mountain Indian's blood is so rich in red cells, it is thicker and more viscous than that of lowlanders. And since the Andean's heart must pump harder at these heights, it is about a fifth larger. Its beat is also slower. The Andean's body is squat and compact, which means that the blood does not have to be pumped so far each time it circulates. At the end of his broad, stubby extremities are an unusually large number of direct passages between small arteries and small veins. This quickens circulation and enables the Andean Indian to go about unconcernedly with hands and feet uncovered at times when lowlanders would suffer severe frostbite if they tried it. Like birds, these people can walk barefoot in the snow without discomfort. So that's fascinating. And a change in how the blood is formed would be a reasonable adaptation in Bigfoot, at least the ones up north. And Bigfoot walk around perpetually without having any kind of covering on their feet. So the very adaptations that the Andeans possess would theoretically be adaptations a Sasquatch would have as well. I think if you were to obtain any blood samples, the makeup of the blood would be very interesting to see, especially for those, again, up north. So in like the Yukon or Northwest Territories or something, that would be very, very interesting. Now, I would like to read off a bit from Dr. Grover Krantz's book, Big Footprints. It's one of my favorite Bigfoot books. Quote, "There is considerable evidence for the existence of a thick pad of tightly compartmentalized fat under the soles of the feet. The first indication of this was in one of the U.S. Forest Service casts from the Blue Mountains in 1982. A foot, real or fake, was pressed into the ground directly on top of a stone that projected nearly an inch, or 2 centimeters, up into an otherwise nearly flat footprint. According to police fingerprinter Edward Palma, skin detail can be seen evenly distributed over the rest of the print, thus indicating a single impression with no rocking of the object around the intruding stone. This single case suggests that there was a fat pad more than 1.5 inches thick, 4 centimeters, in this mid part of the foot." So a thick layer of fat, in addition to the increased capillaries and the change in how the blood is circulated and the very makeup of the blood, would make sense in the northern regions. The fat on the sole also makes sense because even if a Sasquatch rarely reaches 9 feet in height, if that, you are still looking at a massive creature. I've gotten into discussions with people where I said I really don't believe they, on average, get any taller than 8.5 feet, and they act like I've shrunk Sasquatch down to being a small species. No. You have no idea how big that would be, do you? I think a lot of people really just don't know how big they are guessing Bigfoot to be. 8.5 feet is a monster in size compared to us. Even to me and to my older brother, who's 6'6". 8.5 feet is a monster compared to me. And I've known people who thought of me as being almost monstrous in size compared to them. I mean, oh my gosh, you're so tall. And they're craning their neck up to look at me because they're like 4 foot. I mean, it's insane the size differences between me and them, but let alone between them and it. I mean, you're looking at a massive size difference. And so a lot of people who see Bigfoot, you know, they're of average height. They're probably around 5'9" to 5'11". And, you know, an 8.5 foot tall creature, or just a 7 foot tall creature, is still big to the point where unless you have an absolutely firm measurement marker to look at, I have no reason to believe that the creature was 10 feet tall like some people claim they are. It probably was only 7 or 8 feet tall. At most, maybe 9 feet in height. Because anything bigger than that is a monster in size. It's just gigantic. I mean, if you get the opportunity to stand near a statue of that size, you'd see what I mean. Because just taking a ruler up and putting it in the air really doesn't help you. It's like a blue whale. 100 feet stretched out on the ground doesn't really look that big. But if you saw one in real life, you would, you know, about have a heart attack seeing that thing that close to you. I mean, it's massive. So, you know, if you were able to stand by a physical representation of that height, I think you'd see just how big 9 feet is, 8.5 feet is, even just 7 feet in height. Because that is a big creature. 10 feet, 12 feet, like some people have reported, 15, 20 feet? Good Lord, no. No, they do not get that big. I can just flat out say it, at least for that 15 and 20 foot marks. Like, that is just absurdly large. But, you know, again, maybe 9 feet in height. That's still a very big creature. And so, you know, the weight would need to be cushioned, and walking on hard rocks and sharp objects, you know, would become easier if you have a thick pad of feet on the sole, or if you have a thick pad of fat, excuse me, on the sole of the feet. I know elephants have a thick pad of fat on their feet. And a soft layer of fat would also explain a lack of tracks on a number of substrates. If you look at a boot, you're looking at a 90-degree sharp edge on the sides and hard rubber. That leaves an easier impact than does flesh and fat and movable tissue, especially if it's oversized, like for a moose, you know, having a large foot. Well, they still have a hard hoof. If you replaced that with soft tissue, I don't think you'd see nearly as many moose tracks, except for the very muddy, very easily impressionable substrates. So, you know, on enough substrates, the track would be fairly indiscernible, and on some, you wouldn't even see a track at all. And a soft foot would help them sneak up onto prey and sneak away from people without much noise, which is a commonly recorded trait. It seems like a lot of the time Bigfoot walk around kind of stomping their feet, but they can go really quiet when they need to, according to a lot of the accounts I've heard, only breaking a branch or two, just like mountain lions, just like moose, just like elk. I mean, it's amazing how quiet some of these animals can become if they want to be. And so Bigfoot having large feet that helps them steady themselves, and having a fat sole, a fatty sole to help them absorb and cushion some of that impact, you know, would help them be quieter. Now, the counterbalance to having short limbs may be that the individuals with the longest arms had the best ability to scare off predators, and longer arms could come in handy in steep terrain where, you know, if you're looking at a 45-degree or steeper rocky hillside and you're trying to run away from a predator, I mean, those with the longest arms can grab rocks, can grab tufts of matter and just kind of propel themselves up and away from the predator. If you look at not that long ago, you had some very large predators like American lions and smilodons and whatnot. And so, you know, if you're trying to run away from one and you're going up that kind of terrain, the ones with the longest arms can grab handholds and propel themselves a little bit more easily than those with short arms. And again, scaring off predators. What do you do when you see a bear? Depending on the situation, of course. With a mother bear, you do not do this. You try and stand tall and you wave your arms and you try and make yourself look as big as possible. Don't do that with a mother bear. I'm going to repeat that as many times as I need to. Do not do that with a mother bear. She will kill you. This also would, like in a human rock climber, allow yourself to climb rock faces, even very steep ones, 90 degree, to get away from predators or to access areas that are closed off to other animals. It may also have allowed individuals to throw rocks more efficiently. That's something that Sasquatch have been reported doing regularly and quite well. When you're looking at ptarmigans, grouse, turkeys, ducks, geese, marmots, all of those different prey animals, you know, it would be very hard for Bigfoot to sneak up on one and catch one unless it's sleeping. But if you throw a rock at it and you whap it in the head, you know, just like, you know, why people carry guns, like I know I do, you know, why people use a bow and arrow to shoot turkeys, you know, you don't need to get too close to them and you can kill them like that. I've never gone turkey hunting, but I have done grouse hunting. And, you know, you can't get close to one, but your shotgun can. So if you're throwing a rock to hit your prey, you could potentially have an easier time catching that prey and then eating and surviving and passing on your genetics if you can throw those rocks very well. And if you have longer arms, that would probably allow you to do that more easily. But a balance between long arms and short arms is necessary and has seemingly been reported. But I want to get back to that article about huskies, just have a little snippet here. Dog feet have several mechanisms that keep them warm. First, their veins and arteries run very close to one another, creating an intricate heat transfer system from warm arterial blood to cold venous blood. Second, they have a type of freeze-resistant connective tissue and fat in their paw pads. The end result is that a dog's paw is about as good as a penguin's wing in staying warm. So I thought that was pretty neat. And now let's look at bison real quick. Every year when midwinter arrives, snow can blanket the northern Great Plains. Temperatures can drop well below zero, and the winds can howl unmercifully, and yet bison remain alive and well in the hostile landscape. Indeed, bison have evolved digestive, physiological, and behavioral strategies that allow them to survive some of the harshest weather in North America. During the cold winter season, bison develop thick, woolly coats that help protect them from freezing temperatures and harsh winds. It is said that a bison's winter coat is so thick and provides insulation so effective that when snow accumulates on its coat, it will not melt from the heat of the bison's skin. Their skin also thickens in response to cold temperatures, and fatty deposits appear to insulate the animal. This is important because during winter storms, bison will actually turn toward the storm, hunker down, and wait for it to pass. With thick coats creating a low profile, bison can survive the same storm that would kill many domestic livestock. Bison also have the ability to use their large head and massive neck and shoulder muscles as snowplows to forage in snow as deep as 4 feet. But what is perhaps most impressive is how eating grass allows them to have enough energy to survive the winters. Think about it. In winter, a big hearty stew full of meat and potatoes sounds pretty appetizing to many people, myself included. We crave those large filling meals to keep us warm in the middle of winter. Could you imagine eating only stalks of celery after skiing or working in 0-degree weather all day? Well, that is almost exactly what bison do, and they have adapted to efficiently find nourishment from low-quality forage that allows them to battle blizzards, minus 40-degree temperatures, and 50-mile-per-hour winds. Under cold stress, bison have developed the adaptation to minimize nutritional needs and slow their metabolism to conserve energy. Metabolism is a term used to describe the process by which our bodies convert food into energy. People say bison during the winter are time minimizers rather than energy maximizers. In other words, bison cannot merely eat more food and more often to compensate for the low nutritional forage they eat. Instead, they slow down their metabolisms, the amount of time they spend foraging, and the amount of food they consume in order to conserve energy. Forage is retained longer in their gut due to the increase of indigestible plant material found in the winter, which allows them to eat less but still receive the nutrition they require. Without these adaptations, surviving the freezing temperatures and blizzard storms would not be possible. So I thought that was pretty neat, and that's from the National Park Service. So, bison are incredible animals. I'm so glad that they have not gone extinct and that we've been able to recover some of their numbers and recoup them, because bison are incredible. So now let's move on to the infamous polar bear. Polar bears, Ursus maritimus, are well known for their white fur, which makes them almost invisible on the Arctic sea ice. But in areas where it can drop to far below minus 30 degrees Celsius in winter, finding a way to stay warm is vital. Polar bears are warm-blooded like us, with a body temperature of about 98 degrees Fahrenheit or 37 degrees Celsius. But they are invisible to night vision goggles that pick up the infrared rays that warm-blooded creatures, including humans, give off. Why? Nature has given polar bears enough insulation to prevent body heat from escaping. They are toasty warm and comfortable in the frigid Arctic. In the water, polar bears rely more on their fat than their fur to keep out of the cold. Wet fur is a poor insulator. That's why mother bears don't like to swim with young cubs in the spring. The cubs don't have enough fat to stay warm. A recent study at the University of Buffalo found that polar bears have also evolved genes that produce more nitric oxide than other bear species. Nitric oxide is a signaling molecule, and one of the mechanisms it controls is whether cells use their available nutrients to produce metabolic energy, or simply convert it into body heat. Polar bears seem to be able to divert more of their body's resources into generating heat. This relies on them getting enough fuel for this process, and adult polar bears have a high-calorie diet. They mostly eat seal blubber. Polar bears are built to withstand some of the coldest temperatures on the planet. Their brown and black bear cousins avoid the winter cold by digging dens and sleeping. But except for pregnant females, polar bears spend the Arctic winter outside, where temperatures could be minus 40 degrees Fahrenheit, which equals minus 40 degrees Celsius, and windy. That's too cold for humans. You could go outside, but only for a few minutes, with every part of your body completely covered. And if you didn't wear goggles, your eyelashes would freeze and break off if you touched them. So yeah, don't do that. Now let's look at something that I find very interesting here. It's about the mountain goat. According to Life Above the Timberline by John George in the book Marvels and Mysteries of the Animal World, quote, Slashed across the tops of the tall mountains of the world lies a cruel no man's land where howling winds make dwarfs of trees and ice beats grass and flowers to a mat. The sun punishes, ice and rocks avalanche. This is the land above timberline, beautiful but harsh, dangerous where seemingly nothing can live. And yet life has grubbed a toehold there. Not ordinary life, but creatures that have learned to live with unbelievable hardships. I first became intrigued with the ingenuity and endurance of life beyond the trees some years ago when a mountaineer, sitting at a campfire in the west, his ice axe still on his belt, pointed to a black peak against the stars. If a black-eyed mountain goat hadn't known that mountain better than I do, I wouldn't be here tonight, he began. 3 days ago, I was crossing a glacier when suddenly I noticed a puff of dust rising, like smoke, from the hanging wall just below me. I knew it was the first signal of an avalanche. I thought my time had come. A mountain goat, who had been feeding off to my left on a windy ridge, suddenly tensed. His big hump back quivered under his white fur. The mountain was telling him to run. He bounced to an ice wall, sized it up, and sprinted out of sight. I turned and followed. At least it was a chance. I learned long ago that all animals of the high country know the mountains, but wild goats know them best. Some people think goats keep alive up there just because they can run away from avalanches and leap from enemies, but it's more than that. They know every crack and cranny. I ran to the wall, slammed my axe into the marks he had made with his hooves, and heaved up his route. There were ledges and hand grips for me that I'd never guessed were there. Struggling over the top, I rolled onto solid rock just as an artillery explosion sounded the collapse of my trail. As he talked, I stared at the peak and wondered what other intelligent life lived in those bleak rocks, and how they made out in blizzards and storms and relentless sun. A year later, I stood at a tree line in the Colorado Rockies. It could have been the Grand Teton in Wyoming, Mount Rainier in Washington, or any of the many mountains that stretch above 10,000 or 11,000 feet. A wind that dried my face was cold as it funneled down a pass from a glacier. The snow still covered the northern slopes. I could see no life at all. I could hear nothing but the wind. Suddenly I realized that a big Rocky Mountain sheep was staring down on me, his pantaloons blowing. I stared in disbelief. He was fat and comfortable, standing in nothing but wind and snow. I saw no food for him, but presently he leaned down and ate, and I realized the mountaineer was right. The animals of the high country do know their mountains. The wind had swept the slope, exposing the sweet grass. He sprinted down from his meadow and, lightly running over a talus slope, disappeared around a boulder. I followed him, remembering that the sheep, like the goats, knew the best trails. The Forest Service understood this. At the turn of the century, it tossed out its own blueprints for mountain trails in favor of trails built by sheep and goats. These routes were longer but out of the wind and sun, which is just as killing as the cold in the high country. The first thing I learned from the ram was that knowing where to walk is not enough. You also have to know how to walk. Loose rocks went out from under my clumsy feet like a nightmare, and I slid 50 yards to the bottom of a moraine. The ram walked on, up on his own switchbacks over ice and snow. He stepped to a high pinnacle, looked down at me, scratched, and leaped to another pinnacle. He alighted with stiff, shock-proof legs and was instantly rigid. His control was breathtaking. Several days later, I saw a group of females and lambs in a wide, high meadow. The ram was a speck above them, grazing the small, lonely patches that took skill and endurance to find. For the sheep, it was women and children first at the easy pasturage until November, when the ram would join them. Head down, he would drive his curling horns against those of a rival, shaking the mountains like thunder. On all the high peaks of the world, members of this remarkable group of animals cavort and sprint on the edges of cliffs and dash along sheer precipices. The Himalayas have the shy ibex, the Andes the alpaca and llama, and in the Alps the chamois capers on boulders where lesser beasts fear to go. The chamois is like our own mountain goat. He must use the environment as a shield against enemies, walking with a sheer wall rising on one side and a tremendous drop on the other. But, for all his intelligence, his mating ritual seems poorly planned. The stag lives alone until September 1st, according to mountaineers. Then he leaves his hideout and follows his trail to his harem and kids. When he finds his family, the rigorous rutting begins. His horns slash open his rivals. His voice rumbles like an avalanche. He does not sleep. He does not eat. And when he turns to leave 2 weeks later, he is gaunt, thin, and exhausted. Drifting off to his solitary hideout in poor condition, he faces the famine of winter. After watching the goats and sheep on several trips to the timberline, I began to understand how they survived. Other animals share this ability to adjust to such rigors. The marmot is one of the most surprising. It is a hibernator. Most hibernators need long springs, summers, and autumns to store up food. However, the whistling marmot, who in his high-altitude home actually does whistle, has only 2.5 months at the most to get fat for winter. For a long time, it was believed his secret was to eat from dawn to dusk without stopping. But on a camping trip to the high country, I watched a marmot who spent most of his day running in and out of his den. He was seldom in his meadow feeding. I asked a mammologist who was with us what he made of this idleness, and he told me that the remarkable secret of the marmot's survival in the mountains is the animal's unique metabolism. All of a sudden, toward the end of the season, these fellows can put on layers of fat in no time at all, on no more food than usual. So I thought that was very important. One feature I see in the Patterson-Gimlin footage, and this is assuming that it's really a Bigfoot, I really don't know how to feel about that. The entire thing is an enigma. I mean, you can make any kind of argument you want for or against it. There's only so much you're going to get out of it. I mean, I know a few people have even theorized that she has curls in her hair, that she has a purse, and I don't see it at all. I don't really see why she would have one either. I think a lot of people, both for and against, get a little too worked up over it instead of just recognizing that it is an enigma. There's not a lot you're going to get out of it anymore, and just kind of leaving it. A lot of people kind of hammer at it. And, you know, some great pieces of information have been gained, but there's a lot about it that I just don't think we'll ever really truly know. But if you look at the back as it's kind of turned and walking away, it does look like it has back fat on it. And, you know, that could explain how they survive so well, is fat. And, you know, if they start eating as much food as possible before winter, not because they're going to hibernate, but because they need to put on some fat as extra food source to help them stay warm, you name it, that would make sense. I don't believe Bigfoot hibernate, but I do believe that they may nap for long periods of time. You got to remember, bears are actually pretty close as an example, because they aren't true hibernators. They get up frequently, and they aren't technically a hibernating animal. I mean, they try to hibernate, and they do count as hibernators, but they aren't the same type of hibernator that you'd see more than likely for the marmot and other smaller rodents that are out there. I believe frogs also are hibernators. They'll get into the mud at the bottom of a pond and just kind of rest in there. If I'm not mistaken. I need to look into that one further, but a lot of animals don't get up at all as they're hibernating. Bears do. And you know what? Maybe the reason why some people have gone missing is that they did stumble across a den where a Bigfoot was, and it went out and killed them because it was angry. That does happen with bears quite a bit. And it happens with people too. When they get angry, they'll try and go at you. You know, if you wake somebody up who's trying to sleep, you know, you might get that reaction depending on who you're dealing with. So just saying. But I think it's important to note that avoiding the rain isn't the only important thing that a Bigfoot would need to do. Avoiding the wind is equally as important, if not even more important. Wind can cut through insulation and chill to the bone. I believe I made that comment earlier. Wind is horrible. But let's move on to the last two that we have, and then we'll kind of pick up some speed here. Let's go to the woodland caribou. The book Wild Animals of North America by the National Geographic Society said this: "Slogging through the snowdrifts of their northern wilderness home, caribou are well adapted to their environment. Air-filled hair coats worn over thick fat provide extra warmth without extra weight. These built-in life jackets enable the caribou to swim faster and easier than other deer. Raised white tails and surrounding white patches signal alarm. Broad cleft hoofs function as snowshoes, and stiff bristles below the fetlocks furnish a non-skid tread. During the long Canadian winter, small bands of woodland caribou wander through the northern forests, descending into tamarack and cedar swamps to avoid the coldest winds and heaviest snows. Trimmed with heavy yellowish-white manes, their dull grayish-brown winter coats become a deeper brown in summer. By June, the bands have broken up, and the does have their fawns in solitude. The youngsters match their mother's color,
with white spots barely visible. Caribou fawns, unlike most others, are never hidden, but precociously follow the doe in her wanderings a few hours after birth.
On hot days, caribou often emerge from the woods and wallow in shallow lakes, trying to escape the black flies and mosquitoes. Rising old bulls shake themselves like dogs after a bath. Perhaps the abundant moss and lichens within its range explain why the woodland caribou bulks larger than the barren ground group or the closely related reindeer. Now comparatively scarce over most of its range, the woodland caribou once migrated into Maine, New Hampshire, and Vermont, as well as northern Michigan and Minnesota. Years ago, however, it was hunted out of these areas. Now let's look at the white-tailed deer, and let's check out the wonderful book by Leonard Leroux III, The Deer of North America, once again. To the deer, snow may be many things. It can force deer to move, or it can keep them from moving at all. Deep snow can be a trap or a blanket. It can provide the deer with food by bending down the branches of trees and bushes, or it can deprive them of food by burying it. It was the threat of deep snow that forced the migration of the mule deer and blacktails down from the high country in autumn. It was the cold wind before the coming of the deep snow that forced many of the whitetails to abandon their regular haunts and seek shelter in the swamps and in the gullies and draws along watercourses. Yarding areas are not chosen because they provide food. They are used despite the fact that often little food is available there. The main requirement of a yarding area is protection from the wind. Cover is more important than food in areas of cold weather and deep snow, even though the nutrition of the food available is low. Not all whitetails yard up every winter. It depends upon the winter. My area of New Jersey is on a dividing line. Deer in the areas south of here almost never yard up. The winter of 1960 to 1961 was exceptionally cold with deep snow, and the New Jersey deer yarded up most of the winter. We have had comparatively mild winters since that time, with only a couple of years when the deer retreated temporarily to sheltered areas. Our deer were yarded up in the winter of 1976 to 1977 because of the extreme cold and strong winds, although we had only a moderate amount of snow. Fortunately, our deer were able to move out to seek food as soon as the weather moderated. In New York and upper New England, extreme cold and wind, coupled with deep snow, took a terrible toll on the deer. Thousands upon thousands perished. In most warm-blooded creatures, man included, the basic metabolism rate speeds up as the temperature drops. Basic metabolism is a measure of energy requirements, since if a creature's body temperature is to be maintained, heat production must equal heat loss. It is like running a furnace under forced draft. You can raise the temperature, but this requires extra fuel. This is why it is vital for anyone who expects to be out in cold weather to carry emergency food to prevent hypothermia. A few years ago, biologists discovered to their great surprise that a deer does not respond to cold in this manner.
It had been known that young animals of all species have a higher basic metabolic rate than adult animals, and that the larger species have a lower basic metabolic rate in proportion to their body size than the smaller species.
This is another reason why the northern members of a single species are larger than are their southern counterparts. Males of many species, including deer, are larger than the females, and yet they have a higher basic metabolic rate. Bucks are usually larger, grow faster, and are more active, curious, and independent than does. They leave their dams sooner than the females, and they get into more trouble through their curiosity and independence. Owing to all these factors, bucks burn up their body reserves faster. Most adult bucks do not go into the winter season with as good body reserves as the females, unless they have access to almost unlimited food after the rutting season. Unfortunately, this is seldom the case, and winter mortality is therefore usually higher among adult bucks than does. Nature seems to have foreseen this situation and counteracted it to some degree by providing for the birth of more male than female fawns. The basic metabolic rate for a deer requires about 1,140 calories per day for each 100 pounds, or 45.4 kilograms, of body weight, if the air is 32 degrees Fahrenheit, or 0 degrees Celsius, or higher. This metabolic rate drops instead of speeding up when the temperature gets below the freezing level. Because of their lowered metabolic rate, deer will lose 12 to 15% of their body weight in cold weather even if they have an abundance of food. They simply do not take in as much food, nor could they utilize more even if it were available in the winter. And an abundance of deer food is seldom, if ever, available in the winter. The glands of the deer's endocrine system, the adrenals, pituitary, and thyroid, are at their smallest and are mostly inactive during January and February, the period of the coldest weather. When winter begins, the deer have not adjusted physiologically to withstand the severe weather, and they respond by heavy feeding. If the temperature drop is slow and steady, the deer adjust to the slowing down of their endocrine system and become adapted to the cold. If the temperature drop is very sudden, severe, and prolonged, they may go into shock and die. Once the physiological adjustments to the stress of winter's cold are made, the deer voluntarily fast, seek cover, and hold their daily activities to a minimum. After the endocrine adjustments have been made, they can then withstand a sudden and severe drop in temperature without dying. During a heavy snowstorm, deer will lie down and not get up unless disturbed until a storm passes, even if it is of several days' duration. They literally become buried in the snow. The insulating qualities of their coats are so efficient that the snow won't even melt. And the covering of snow itself also acts as insulation, giving the deer additional protection from the cold. It has been found that deep, soft snow is important to the survival of moose. They lie down in it so that the snow actually envelops their bodies. Deer don't do this. Deer paw down through the snow to the leaves below, if possible, before lying down. Moose will not use their snow beds a second time, whereas deer use the same beds again and again. On numerous occasions, I have seen a large buck and even an adult doe drive another deer out of its bed and then lie down in the same spot. This habit of pawing out a hole in the snow costs the deer vital calories because the snow would be a more effective blanket if it enveloped the animal's body. Deer do not take advantage of this as some other species do. This supports the theory that the deer living in the north today got there through range expansion, an expansion that is going on. They did not evolve in the north. Their habits change drastically in the winter. Most of their activities are now during daylight hours. They remain bedded through the long cold nights. They do not bestir themselves even at dawn. About 8 o'clock a.m., as the sun comes up, they begin to feed if any food is available. Lying still at night conserves energy, and feeding the daylight hours also helps. Even on days that are clouded, the air temperature gradually rises so that less calories are burned for heat during the periods of activity. The deer will avoid windy areas wherever possible. They like to feed on steep mountain slopes that face south, southeast, or west. They will sometimes utilize almost vertical slopes. The snow is usually lighter on these slopes, and here it usually melts off faster and vegetation is usually heavier. Deer will also choose these areas as bedding sites to take advantage of the sun. However, if the temperature rises above 40 degrees Fahrenheit or 5 degrees Celsius, they will seek shade, even in winter, because they become uncomfortably warm in their winter coats. So here is the thing that you have been waiting for, the summary. I mentioned this earlier, but rain is likely the biggest worry a Sasquatch could have. Water wicks away your internal temperature, and that rain can likely get through their guard hairs and hit their skin unless they have a layer of oily guard hairs underneath. However, this isn't likely except for perhaps the most northern environments because of how badly they would suffer in hot temperatures. It's likely that possessing this theoretical adaptation is why more accounts of aquatic behavior are noted in Alaska than anywhere else. Raincoast Sasquatch goes into that more. Why nests are likely made is something that comes up a lot. And I think it's because ground nests are made not because they're trying to seek shelter from the environment, because people have called that out. Why are they building a nest if it's open and exposed to the air? Well, I don't think it's to stop the elements from getting to them. It's to stop their heat from being sucked out through the ground. It's to prevent heat loss going into the ground. Their hair is like any insulation. Compression removes the insulative value. So laying on a bed of sorts, it doesn't even need to be very good, prevents complete compression of their hair against their body. And the hair on the portion of their body not touching the bed will likely have enough insulative value so as to keep them warm overnight. One of the things that you learn hiking and camping is that you want to get up off the ground. You want to have a sleeping pad of some sort, whether you use natural elements or one that you brought with you, because if you touch that ground and you sleep on it overnight, the ground will just remove all the heat from your body and it can kill you. So you want to get up off the ground. And so some of these nests could likely be their way of getting around lying on the ground directly. One of the only creatures I've ever heard of that has hair that resists that compression issue is the panda. In the book, The Great Bear Almanac by Gary Brown, this was said: giant pandas, according to George Schaller et al., have a short, thick coat that provides excellent insulation. The animal readily sleeps on snow. The density and oily texture of the hairs probably prevent moisture from penetrating to the skin, an important adaptation in a damp, cool environment. And the hairs have a springy quality. They are resistant to compaction, which reduces heat loss when the panda lies on snow or cold ground. Now, one possible explanation for the occasional report of a sagittal crest could be that there are hairs on the top of the head that are stiff, just like the peccaries. And when nervous, scared, or angry, they lift up like the hair on a dog's back. I personally favor the idea that they occasionally have a trichilemmal cyst on the top of their head that just grows and grows and grows, and after a while pops. As you can see by this picture, this poor man had quite a doozy on his head, and that has that kind of conical shape to it. They don't necessarily have good skin care, and they don't necessarily have people to help them pop those things. And, one explanation for why Patty, the Patterson-Gimlin Bigfoot, was caught on camera in the first place was maybe she had one of those, because it does look like she has one of those sagittal crests. Well, if she had one of those, a trichilemmal cyst on her scalp, you wouldn't be able to see it very clearly. You just see that generalized shape on her head. And if it got whacked by a tree branch as she's making her way down to the creek, all she wanted was water. She was heading down to the creek. She got whapped in the head, dazed and confused. She's just trying to drink some water, and then she hears maybe elk walking towards her, and then she sees that there's people, and she's in a confused state. There's a lot of pain and throbbing going on, and she's just trying to walk away from them and get away. She's confused about what's going on. And that could explain why that Bigfoot was caught on camera if it's really a Bigfoot and not a guy in a suit. It makes more sense than some of the other explanations I've heard. And, some people have noted that they saw a Bigfoot with a sagittal crest, and then later on they saw what looked like the same individual, and it didn't have one anymore. That could be it. At least I seem to remember hearing cases like that, but I can't really pin them down anywhere. But I do know people have reported seeing different types of Bigfoot. Well, it could just be that one had a trichilemmal cyst, and then it popped, and it didn't have that anymore, and had more of a rounded skull. Their dark hair color and dark skin color. The hair color is typically black, and the skin color, I've heard some various different things. Some people say black, some people it's more of a brown, some say it's more of a gray. As far as the hair color, it can be more of a red, it can be more of a brown, but all those colors do absorb heat, but especially the black, and that would help them absorb heat from the sun. So, early in the morning, getting out there and searching the sun-exposed, like rock outcroppings with a thermal camera, I think would be fruitful. On cold mornings, it would be likely for them to want to get out and get some sun. Also, checking those slopes that are out of the wind. Any little gullies and areas that are out of the wind, anything would probably be a good idea. It's possible that they do use snow dens, and if that is the case, then they would likely be mistaken as a bear. And it's both illegal and considered morally wrong to shoot a nesting bear, and it's very dangerous. There are individuals like biologists that will go out into the woods and try to find bears, to tag them, to check on them and see what they're like, see what they're doing, how they're doing. But most people that are out there are going to be your average Joe, and there are a lot of average Joes that go missing. And so if people do walk up onto one of their snow dens, it would have to be purposeful, because they'd probably be off the trail by a little ways, and you can end up getting attacked. And that could explain why there are some people who've gone missing for no apparent reason. But, they might not use a snow cave. If they, hunker up, it may be under a tree. They may crawl into the snow and just let it envelop them like the moose do. It's a little hard to say. They may try to keep moving and only hunker down at night, again, maybe under a snow-laden tree, something. I do not know. I want to go into a couple more possibilities in a moment. I do want to say, though, that Bigfoot are reported to have large noses, and so I have wondered why that's the case, because if you look into a lot of the eyewitness statements, a lot of these AI pictures of an ape-like nose are not correct at all. Most people don't report that. The type of nose that they are reporting is the one that is flat to the face and wide. And you can kind of see the inside of the nostrils a little bit, because it's like a hooded nose. And I've only seen a few people with that type of nose, but there are a few that you can look up and you can see. And that type of nose is typically associated with warmer climates. So Sasquatch, a creature that supposedly lives in very cold areas, kind of sticks out like a sore thumb there. And that may be a reason to have some alarm bells ring. Maybe Bigfoot isn't real. After all, according to Penn State University, the researchers noted that the positive direction of the effects indicate that wider noses are more common in warm, humid climates, while narrower noses are more common in cold, dry climates. It all goes back to Thompson's rule, Arthur Thompson. In the late 1800s, he said that long and thin noses occurred in dry, cold areas, while short and wide noses occurred in hot, humid areas. Many people have tested the question with measurements of the skull, but no one has done measurements on live people. One purpose of the nose is to condition inhaled air so that it is warm and moist. The narrower nostrils seem to alter the airflow so that the mucus covered inside of the nose can humidify and warm the air more efficiently. It was probably more essential to have this trait in cold and dry climates, said Schreiber. People with narrower nostrils probably fared better and had more offspring than people with wider nostrils in colder climates. This led to a gradual decrease in nose width in populations living far away from the equator. This is not the only explanation for nose shape variation in humans. The researchers also found differences between men and women in nose features across the board. This sexual dimorphism is not unusual, as human men tend to be larger than human women, and their noses would be larger as well. Now, one possibility is that the founder effect took hold, and the shape of the nose became more pronounced over time as the population of creatures in the U.S. may have been relatively small. However, if Sasquatch are direct descendants of Homo erectus, like I have tentatively posited, then the nose shape makes sense. It's thought that they possess a broad, flat nose. Not all creatures with a large nose have a hard time enduring cold weather. In fact, the Saiga antelope, a creature you may never have heard of before, is a fascinating one, having roamed the earth since the Ice Age and outlived mammoths and saber-toothed tigers. Once migrating across arid plains in Eastern Europe, Asia, and Alaska, they are now only found in smaller regions in Kazakhstan, Mongolia, Russia, Turkmenistan, and Uzbekistan. According to florafauna.org, the Saiga antelope's nose is undoubtedly its most distinctive feature. This bizarre bulbous appendage is an adaptation that enables the Saiga to survive the tough conditions and extreme seasonal temperature swings in its native habitat. The swollen nostrils filter out dust and cool the blood during hot, dry summers, and act as a radiator in winter to warm the cold air before it enters the Saiga's lungs. Another interesting point I want to bring out is that moose as well have an interesting adaptation. Inside their nose, they have a set of valves, actually, that can close automatically underwater. Animals like horses, dogs, and cats can't close their nostrils. Lawrence Whitmer, a biologist and professor of anatomy at Ohio University, said, "Closing your nostrils is a common aquatic adaptation, but you don't see it in other members of the deer family. When a moose dips its head under the water, the difference between the water pressure and the air pressure causes the nostrils to close. This adaptation, perhaps the main reason a moose's nose is so long, allows a moose to feed underwater without flooding its nose, an unpleasant sensation even for two-legged, short-nosed mammals like us." Polar bears also have a long nose that helps them endure the cold. Now, that doesn't necessarily have anything to do with Bigfoot, but with how many aquatic sightings there are of Bigfoot up in Alaska, maybe that is something that they possess. I do not know. And that would help them with the cold because now their nostrils aren't exposed to that cold weather anymore. It shuts out the cold and stops it from reaching up into their nostrils. So that's a thought, although I feel like that one's kind of reaching. But the main point here is that moose as well do warm up the air that they breathe. They have very large noses and nostrils. The Saiga antelope has a very large nose and nostrils. The polar bear as well has a very long nose and big nostrils, and yet they don't have a lot of issues with cold air. So the idea that Bigfoot would have a problem is based upon us and not other animals. Now, to be fair, those other species have a long nose. Horizontally, it stretches out, whereas Bigfoot would just have a wide nose. So it may not compare directly, but it is a thought. Just wanted to put that out there. So, even if their noses are a weak spot, unlike the Saigas, it should be noted that their bodies are overall pretty well adapted to the cold. They have long fur that in some areas may lack a medulla, but does not exclude the possibility of one. Again, each individual hair will look different. And a lot of the hairs that were collected seem to have fallen out naturally. Maybe they were shedding their hair. I do not know. Hair can be hard to find and even harder to identify though. So, the idea that we just find piles of Bigfoot hair is not really that realistic. Anyone who goes out there and tries to find animal hair will tell you that you have to look in specific spots, but that doesn't mean you'll necessarily just find hair. Even when you know what to look for, but especially if you don't. They are hairy year-round, so perhaps the hair lacks medulla because they don't shed their fur every year. Perhaps this is a sign that they are very much a human-like creature and are perhaps related to Homo erectus. Now, I want to note that people say, well, Homo erectus, it wasn't hairy. That's not known, actually. That is inferred. No evidence that I found can conclusively state that Homo erectus wasn't hairy, at least at some point. It's a conclusion that is a logical assumption, but it's based off of the idea that we're directly related to them. And so we lost our hair at some point because we're directly related to primates, and because we are a primate of sorts, but we're directly related to the common ancestor of chimps, let's say. And so, Homo erectus seems to be on that same lineage. And so somewhere along the line, our family line lost hair. And so it probably happened with them. That's the general conclusion. But it isn't known. And there's nothing stating that Homo erectus is directly related to us. We haven't been able to really figure that out yet. It's inferred. It's a logical assumption, but by no means is it fact. Not yet. It's also based off of the assumption that they were long distance hunters. And so, just like Bushmen, they would run for long periods of time, sweating and not having hair in the way would allow them to be more efficient hunters, and especially on the savanna and whatnot, they would not have nearly as many issues heating up, and they would be more effective and more efficient. However, some are rethinking the possibility and beginning to believe that they may have traveled along waterways like rivers, which, if you know anything about rivers, there's a lot of areas where you can hide, you can ambush prey. You can also scavenge pretty well in those areas because there are a lot of other predators and plant eaters out there. And so, the idea that they had to have been endurance hunters was, again, it's seemingly, from what I've found, inferred. According to the article, What Drove Homo erectus Out of Africa? Excavations at a site in northern Israel are at the heart of a debate about the species migrations. A nice long title. Quote, for many years, scholars subscribed to the Savanistan hypothesis to explain hominin journeys out of Africa. According to this idea, Homo erectus dispersed out of East Africa about 2 million years ago as climate change triggered the expansion of East African savanna into the southern Levant. Homo erectus likely stuck close to water sources, lakes and rivers on their generations-long journey, says paleontologist Bienvenido Martinez Navarro of the Institute Català de Paleo, God, I can't say it, in Tarragona, Spain. I'm sorry, I do not have a tongue for that. I have Greek and Italian in me, and you would have no idea by how white my tongue is. I can't roll those words off, so I'm sorry. As scavengers, they probably scrape meat off the carcasses of animals, particularly those killed by saber-toothed tigers. To be fair, though, I believe the saber-toothed tigers weren't actually tigers, so people prefer to call them now saber-toothed cats, but whatever. In essence, the original Savanistan hypothesis suggests these hominins were so adapted to open grasslands and the occasional patch of woods that, as climate transformed environments, they trailed new savannas out of Africa. But finds at Ubidia have complicated the notion that Homo erectus passively followed the spreading savanna. As Bellmaker points out, Ubidia wasn't a savanna at all. It was a woodland covered in trees, something her work has helped establish. Furthermore, Bellmaker has compared the composition of carnivore fossils at Ubidia and 4 other Eurasian hominin sites dating to the early Pleistocene between 2.6 million years ago and about 770,000 years ago. She determined that 2 of the Homo erectus sites, Damanzi in the country of Georgia and Piro Nord in Italy, were inhabited by a wide diversity of animals, including hyenas and dog species that favor open, long-distance running environments, meaning these sites were likely shrub or grassland. Meanwhile, 3 others, Ubidia, Ventimiglia in Spain, and Kalaki in Georgia featured a greater variety of ambush hunters, like felines, which rely more so on trees, suggesting the sites were forested. Bellmaker's findings suggest Homo erectus could thrive in more than one habitat type and was not limited to savannas. Building on this point, she has put forward a different theory of migration. Homo erectus was innately adapted to a diversity of landscapes before groups even left Africa, both hunting antelope on open plains and scavenging in patches of forest. Sites in eastern Africa offer evidence that supports Bellmaker's hypothesis that Homo erectus was well equipped to thrive in a range of habitats. According to research by zoologist Isabel Winder, now at Bangor University in Wales, the earthquake-prone African Rift Valley where Homo erectus evolved would have had rough or irregular landscapes, rich in caves and basins that trapped water and sediments. Not only did these spaces offer hominins places to forage and hide from predators, but the challenges associated with such disparate habitats would have meant that those individuals born with adaptations that improve their survival in multiple habitats, such as feet that act as levers, which help hominins clamber over boulders, would have been most likely to survive and reproduce. As a result, over the generations, Homo erectus could have become more and more versatile. Such complex terrain, which is also found along coastlines, would have formed plausible pathways out of Africa that facilitated the expansion of early Homo, Winder says. These varied landscapes had hills, valleys, patches of forest and water, and diverse vegetation. In addition, Bellmaker believes Homo erectus's adaptations could have gone beyond physical abilities. She argues there was something special. Either biologically, they were smarter, or they had social structure that allowed humans to be successful in these novel environments. If you look at the United States, we have a lot of varied environments. So, these beings being adapted to those types of environments means to me that they would be easily adaptable to the environments here. And we see from way down in Florida and the swamplands there all the way up to the timberlines up in Canada and everything in between, Bigfoot have been sighted, except for the very open areas like Kansas and whatnot. So basically everywhere in between, except for areas that offer no real cover, you see Bigfoot sightings. So I thought that was pretty interesting. And papers such as Bipediality and Hair Loss in Human Evolution Revisited, The Impact of Altitude and Activity Scheduling, by Tomas David Barrett and Robin I.M. Dunbar seem to indicate that there is a substantial decrease in body temperature with efficient bipedal locomotion. Depending upon the length of the hair and their structure, I believe Homo erectus could survive their journey out and perhaps up into the Siberian region and walk along the coast into North America. Now, there are two different possibilities for that. Either the kelp highway, which suggests that boats were used, kind of island hopping, and there were some papers that went into how Homo erectus seems to have developed some sort of boat usage, primitive but still boat usage. So that's always a possibility. But there's also the possibility that as the massive ice sheets that covered Western North America retreated, you could reach North America by foot. And the idea is that they would be able to survive on the abundant coastal resources and just work their way down and into Canada and the United States, which is certainly possible. But whether or not that would work past the dates that they have theorized for Native Americans, which was about 20,000 years ago, and actually apply for dates of about 120,000 years ago or 800,000 years ago, I have no idea. I would like to do some more interviews this year with qualified experts. I have one that I'm possibly getting lined up, and that'll be kind of interesting. I already did one with Dr. Bootersea, who was a fantastic interview. He talked to me about the human eye, because with Bigfoot, there are reporters having different colored eyes. What are some possible explanations for that? And I went over a few different possibilities, and he answered them for me, because I laid out the questions, but I needed the answers, and I couldn't find any online. And he was able to help me out. And I think that was a very interesting interview. I posted it on Potlatch Productions, which is the channel for all of my academic type interviews that I will be hopefully doing more of. And then also here on Idaho Bigfoot. So, hopefully I'll be able to do more interviews with different individuals. But in the meantime, I can tell you that I do know that various different species did find their way into North America, like mammoths and American lions. According to the Natural History Museum's article, North American Mammoth Origins Rewritten, quote, Scientists previously believed that the primitive southern mammoth migrated from Asia to North America around 1.5 million years ago and evolved into the Columbian mammoth. New research shows that the southern mammoth never made it to North America, and that the Columbian mammoth's ancestor was actually the more advanced steppe mammoth, a species very similar to the Columbian mammoth that migrated from Asia into North America over the Bering Strait land bridge around 1.5 million years ago. The researchers also found evidence that Columbian mammoths interbred with woolly mammoths after the woolly mammoth arrived in North America around 100,000 years ago. Lead author and museum paleontologist Professor Adrian Lister says, "Until now, we thought North American mammoth evolution and adaptation ran separately from other continents. This research shows that mammoth evolution is a lot more complex and surprising." So that's pretty interesting. 1.5 million years ago. And then for the woolly mammoth, 100,000 years ago. And then here, according to Husky magazine's article, The Lion, the Land Bridge, and the New World, Whatever Happened to North America's Lions, quote, "The first lions to amble into North America around 165,000 years ago were a lineage of cave lions. When a warmer period led Beringia to flood, the lions were cut off from Asian populations, and they evolved into the American lion," Salas explains. American lions didn't spend much time in the north and instead headed for what is now the United States, he says. Nearly all American lion remains have been found south of the ice sheets that once covered much of the continent, save for the 67,000-year-old specimen from a Yukon site. Salas identified this as the oldest known American lion. According to Alexander Salas, a vertebrate zoology postdoctoral researcher at the American Museum of Natural History in New York, about 63,000 years ago, a second wave of cave lions crossed into eastern Beringia, now Alaska and Yukon. For some reason, these cave lions stayed above the ice sheets, remaining separate from American lions that had already dispersed south. Salas's research revealed that this lion lineage went extinct around 33,000 years ago. So the Bering Land Bridge is the most likely route of arrival, and has been open for a long enough period of time to have been used. So the Bering Land Bridge is the most likely route for arrival into the U.S. and Canada, and it has been open enough for a long enough period of time in the past to have been used. And, you know, Homo erectus being a hunter-type species, it's always possible that they were following predators like those lions and following up on some of their kills, scavenging their kills. The American lions, well, at the time, cave lions, didn't just arrive in North America because they felt like it. There was a reason. And so maybe any members of the Homo erectus clans that were up there decided to go too. It's hard to say. It's all speculation, obviously. Speculation and conjecture. But it's fun to think about. It really is. I am following up on a few different leads that may show that Homo erectus or something similar may have actually arrived in North America, and one of those sites is the Cerruti Mastodon site. So I look forward into going into that in more detail later this year. But doubtless hair serves other purposes than just keeping an animal warm. It can repel insects, as mentioned earlier, and stop them from causing so much damage. When you look at the yellow jackets and biting insects like, ants and horseflies and whatnot, having a layer of fur to stop them makes sense. But, as far as camouflage goes, I mean, that dark black color, that looks like a burnt stump. I mean, if you have ever looked at an area where a wildfire has gone through, you see some really dark black charcoal on the sides of trees, because that's where the fire burnt and it created charcoal. It left charcoal in its place. And, people have reported a Bigfoot standing right there. Its head was down low. It wasn't looking at them. They thought it was a stump, and then it disappeared, or it got up and walked away. And they found out that that wasn't a stump to begin with. So, blending in with some of the trees, makes sense for that black color blending in with the shadows. I have a dog that, even though she has some light brown on her as well, because she's a Rottweiler, you saw her in the last video about whether or not Sasquatch bury their dead, another thorough analysis. The thing is, though, she just blends in perfectly. I mean, you do not see her. She's a shadow. So that kind of coloration makes sense, especially for a nighttime predator. But even during the daytime in shadowy areas, you blend right in. With dead trees, you blend right in. It also can help you stay warm. Again, sunbathing in the mornings. Then as far as the brown color goes, you blend in with trees, you blend in with the earth. That ruddy color, you blend in with pine needles on the ground. I've been in entire sections of forest where the only ground covering, except for small little bits and pieces of ferns and whatnot, are pine needles. They just litter the entire forest floor, and they match pretty closely the color that people describe for Bigfoot. You do also see dead ferns and other plant material out in the woods that have that same kind of ruddy color. And clay. If you ever go to places like Alabama and you look at the earth, I mean, they have that kind of ruddy colored earth, that clay. So no matter where you're at, those colors blend in. And a lot of people say that, well, you know, bears and Bigfoot, they have to be connected because they share the same colors. There you go. All the Bigfoot sightings are bears. I mean, it's really pathetic. If you really go over it, I don't mean this as an insult to anyone that believes that, but if you really go over the details, it does not hold up. For only a section of sightings does it actually hold much weight. I feel that they actually apply more towards dogman sightings because you actually have a similar silhouette and shape, but with Bigfoot, not even close for most of them. The only times where I feel like it can match is when they get down on all fours and run off. And unless you're dealing with something like an ape, like the skunk ape, I'm looking into doing a documentary on that. We'll see how that goes. But, you know, if you're looking at more of an ape, like a orangutan type, yes, getting down on all fours and running off does make sense. But at the same time, that does match the behavior of a bear. So those types of sightings I can see, but most of the time, it doesn't match. If you really look at the details, they just don't even begin to match. But there was a picture that was shared recently in a Facebook group that showed a mountain lion and a, I think, black-tailed deer that went right through the exact same spot on the exact same trail cam. They were both captured, and they have the exact same coloration. Hopefully I have it up on screen for you to see. I don't know about you, but they match almost identically. Their general body shape is different, but the colors are the same, and that's because they live in the exact same areas, and so the camouflage that one uses works very well for the other. Those camouflage patterns work, or lack of pattern, just colors, they work. Bear and Bigfoot live in a lot of the same areas, so having the same types of natural camouflage makes sense. At least for me, that's what immediately makes sense. So, you know, being able to hide from predators and being able to hide from prey to be an effective predator is extremely important. It means very, very much. And I think it has more value than being comfortable on a hot day. You can also hide under trees and stay in the shade, and water can, depending on whether or not crocodiles are present, you can just get into the water and bathe and cool yourself off. If crocodiles are present though, don't try that, not a great idea. It's important to remember that that was likely during the transition between the Pliocene and Pleistocene epochs around 2.5 million years ago onwards. And that's a time period when climates were becoming cooler and drier. So all later species of Homo are theorized to have come into existence during the Pleistocene, which is 2,600,000 to 11,700 years ago. This was generally a time of more extreme world cooling and recurrent glaciations or ice ages. During the coldest periods, global temperatures dropped by about 9 degrees Fahrenheit or 5 degrees Celsius, and long-lasting ice sheets spread out from the poles and high mountains. Between the 4 or more major glaciations of the Pleistocene, there were interglacial warming periods with temperatures similar to now. Supposedly, the temperatures rose to be quite high at times, but at the moment, I do not know the exact numbers again. So it's a little hard to say by what amount. You know, a lot of people feel like Bigfoot live in caves year-round. And, you know, for wintertime, I can see that, going into the caves when people aren't really actively visiting them, you know, trying to get out of the rain, trying to get out of the bad wind again, you know, trying to get out of those elements that could kill them. That makes sense. But I don't think they live there. You know, you'd find a lot of feces, you'd find hair, you know, you'd find bones, you'd find a lot of things there that would tip you off that something's inhabiting that cave. And you know, someone on their own, yeah, I could see them getting killed if they are found, but at the same time, Bigfoot don't tend to be very aggressive creatures from what I've seen. It seems like they will attack people if there's a really good reason. And someone stumbling onto their hideout doesn't seem to be one of those reasons. I mean, after all, a lot of people have found nests on the ground. People up in Alaska and then people over in the Pacific Northwest, they found nests, they found places where it seems like Bigfoot have created tree structures and they haven't been hurt at all. There are guys who go out there on a regular basis trying to find caves, trying to explore caves. Why haven't they found those caves? Should they connect with other caves? It would make sense for them to have found those caves and to have plotted them out, to looked at them, or at least mapped them out and said, okay, there's a cave over here, we haven't explored it yet, and other people would probably want to go look at it, and the gig is up. Forest Service employees and whatnot, you'd think would figure out pretty quickly that there are caves there. And then you have to kind of rely on the excuse that, well, there's a government cover-up. And I think the only time that would actually happen, though, is if they are determined to be human. With apes, just like some of the owls, you kind of have to determine that they're there, and there aren't as many communities as focused on supporting wildlife as there are and there aren't as many communities that are focused on supporting wildlife here as you might imagine. But if you combine the fact that not only are you protecting wildlife, but then you add in the fact that there is a type of human out there, no matter how rudimentary, no matter how far away from us, that it's a type of human, even remotely, that would get people to lobby hard to shut down the forest, stop any kind of lumber cutting, any type of hunting, any of that. I could see it. I can envision some of the efforts that would go on. And, that would warrant keeping it quiet, because lumber provides quite a bit of income. A lot of the fracking that happens out in some of the more rural areas. I hate fracking, so I would not mind that getting shut down. But we need lumber. It's a thing. We need it. It's unfortunate, but I need paper. I brought that up in the past. It is a renewable resource. It's just learning how to intersperse different types of trees, learning how the fungi and the forest floor all interacts with each other, and making sure that you keep that in balance too. And no monoculture, none of that. Keeping it as diverse as possible, making it as much like nature as possible, letting it grow back plenty of time, selectively cutting. I feel like you could do a lot of stuff and it would work out just fine. But if you're looking at purely black and white, what would happen if people found out that there's a type of human being in the Americas that lives out there and we're taking away their home? You can see where they'd want to keep it quiet. And I say they, I mean the federal government, the national parks, that sort of thing. Because, recently we've seen more and more about what happened to the Native Americans, the indigenous people here, the Trail of Tears. I think it was General Custer as well. A lot of things happened to the Native Americans that were just cruel. And so things like reparations come to mind, and there's a lot of civil rights issues that have been fought and are still being fought. And it would really all just come to the fore and really be hit hard if Bigfoot isn't just an ape, but is a type of human, even remotely. And so if they are a type of human, I can actually see that being the case. If they're a type of ape, I don't really see that being the case. Not in a big way, because like with the owls and some of these areas where they do shut down and stop logging in certain areas, it hasn't stopped everything. It's just certain areas that have them. But if there is a type of human that could cause civil rights issues to really flare up, they would probably try and get everything shut down. And I'm not saying that's wrong, but I'm also not saying that's right. It's a complex issue. And I could see them not wanting that to even begin to happen. But, that doesn't explain everything, because you go back farther, to the time of the National Park Service even being formed, people didn't really like the Native Americans as a whole. As a whole, you had the cowboys and Indians type mentality of the bad guy Indians, and you're the cool cowboys. And it's only around, from what I can tell, about the 1990s when attitudes really started to change. When you look at movies like The Last of the Dogmen, when you actually start to humanize the Native Americans in a big way and starting that cultural phenomenon of looking at the Native Americans in a different light. Not that no one had, it's just as a whole here in North America, really looking at it and going, oh my, they're people too. And actually thinking about it and making that connection. Not just reading history, but actually understanding it and putting yourself in their shoes. And I could be wrong. Let me know. But I think a lot of the attitudes started to change around the 90s. And so Going back farther than that, I seem to remember John Muir and Theodore Roosevelt didn't really have a lot of positive things to say about the Native Americans. Sometimes Native Americans were pushed out of where they were placing the national parks. Would they treat a Bigfoot any differently? If they knew where they were living, would they have tried pushing them out? Would they try killing them? I don't know. I don't want to make the National Park Service out to be bad guys either. It's just, I don't think they would have really cared about Bigfoot being human. It would be just some hairy wildman out there to them, and it wouldn't have mattered. It's only recently that you can come up with the explanation that, you'd want to keep it quiet because then logging would be shut down. Not all that long ago, that wasn't even a concern because no one cared. No one on a broad scale, at least. So, you have to start kind of coming up with explanations and reasons. And honestly, I feel like most of the caves have been explored and charted. It's possible for some of the smaller ones, though, to have been maintained. And as far as they go, I could see partial use during the winter time. And maybe Bigfoot would close that up with a rock or cover it with some fallen trees. In fact, let's see here, Oksana Terletskaya's case, if it's legitimate, I'm still trying to find some really concrete sources for it, but if her story is legitimate, she described being put inside of a cave with a little bit of water running through it, and the Bigfoot would close the cave off with a big old rock. And it would roll that rock away to get into the cave. And she was able to escape because the rock wasn't rolled all the way over. She was able to squeeze through and get out of there. It didn't sound like a massive cave. It sounded like a fairly small one. It sounded to be about the size of this room, maybe just a little bit bigger. 20 foot by 10 foot. It doesn't sound like it was a massive cave. It sounds like it was a fairly small one. And something like that, that's localized, I could see that going without being noticed. Because any kind of trails leading up to it would be fairly faint because it's only being used during part of the year. You aren't looking at year-round use, you're looking at the winter months, or when it gets really, really hot and you have to get away from the sun. So during the hottest months in summer, like August, for example, July and August. Nests may not make much sense, like I said, unless they are made simply because you want to get up off the ground. And if that's the case, that would make sense. They cannot be conclusively connected to Bigfoot, though. But if they are legitimate, then with that idea in mind, of them trying to just get up off the ground, then it makes sense. Just because you have hair does not mean you will stay completely warm or perfectly warm at night. Even using efficient insulation, you can still compress it, and at night, the earth can just suck the heat right out of you. So making a rudimentary bed allows you to get up off the ground, and it can help you, or for some of those smaller nests, maybe you're young, baby Bigfoot, get up off the ground and stay warm at night. Especially if all you have is your summer fur and not your thick winter fur, if they do shed every year. But if not, then you still aren't looking at the best insulation there with that fur construction if they do genuinely lack a medulla all over their body. But looking at the big picture, the relatively large sizes, possibly reaching up to about 8.5, maybe 9 feet in height, the very hairy build, even covering the breasts and only exposing small portions of the face, the soles of the feet and hands, the potential construction of the foot as inferred by looking at footprints, the seemingly short for body size arms, and relatively short legs, as determined by some researchers. The somewhat stubby fingers they possess, if you look at some of the handprints, they don't have very long fingers. They seem to be fairly stubby and squared off. The occasionally reported small cave use, like Oksana Terletskaya's case, the nest use, and even the gruesome potential of kidnapping people and causing them to go missing right before a storm or cold weather are all fascinating. And it's sad for that last one, but the rest are just incredibly interesting to me. And honestly, it seems to indicate a real creature being out there, but it's open to interpretation. It could very well represent a real living, breathing being, but it could also be all in our heads. It could be a lot of confabulation kind of spun together. So I'd like to hear your thoughts, guys. My throat is getting really sore. Please like this video and comment down below. Just a small, short comment would help out a lot. I'm not getting a lot of likes on my videos either, so if you could give me some likes and help this video grow, also by sharing the video, clicking that share button, copying the link, sending it, that would be fantastic. I also want to say that those doing field research during winter, I would focus your attention toward areas that are consistently out of the wind, and in the early morning, search sunny slopes with a good thermal camera if you can. I feel like that is a very good way of finding evidence. And if you also try to pay attention to birds' nests, anytime you see a dead, old bird's nest, kind of pulling it apart carefully with gloves on and checking to see if there are any hairs would be a good idea. And making sure that you have the proper equipment as mentioned in Raincoat Sasquatch's book, and making sure that you have the proper equipment as detailed in the book Raincoat Sasquatch for collecting hairs is important. I feel like eDNA is probably going to be the best way of obtaining evidence down the road. Taking water samples and maybe soil samples in certain areas and getting them tested and seeing what's up. I feel like if you focused on the human side of the DNA, that would be ideal. But, you know, thorough analyses would be very much needed. And there's also a technique of where you take leeches and you test them because they do feast on blood. And so leeches should theoretically contain the DNA of whatever species that they were latched onto. So if Bigfoot are in the South, that would maybe be the best thing to do, is try and see if you can collect some leeches to do that kind of DNA testing. Unfortunately, it costs money, and that's the big problem. I'm hoping that as my channels grow, I could maybe afford to do some of that, but I don't know. I'm focusing more on trail cameras because they're a little bit cheaper, a little easier to set up, and I do feel like they hold some promise if you set them up correctly, but I'm still trying to figure that out, and with my knee injury, getting out for a while will not be easily possible, so we'll see how that goes. But if I could get your support, please, and subscribing to the channel, again, doing the whole shebang, liking, commenting, sharing, that would be fantastic. If you want to donate $1, $3, it would go a long way to support the channel by going to the Buy Me a Coffee link down below, buying me a coffee. That would be fantastic. If you want to just mute the ads that play and just let 1 or 2 of those ads play, that would be fantastic. I try to only let 1 or 2 play throughout the video's length. If you could do that, it would be fantastic. That way I can reap some benefit from all my hard work, because I prepared this entire thing just for you guys. So if I could get your help, that would be fantastic. But thank you guys so much for watching. Please comment down your thoughts down below, and I'll see you guys next time. Bye.